Hello everyone, welcome to my channel. This is Vijay Girturi, and in today's video, I'm going to show you a complete end-to-end DevOps project called CloudKitchen. And it's a full-stack production-grade food delivery platform where customers can browse restaurants, explore menus, and add food items to their cart, place orders, make payments, and track their deliveries in real time. And it's similar to popular platforms like Swiggy, Zomato, and Uber Eats. But the main focus of this project is not just the application itself. The goal is to demonstrate the complete DevOps lifecycle using modern cloud native technologies. So now let me open the GitHub repository and the architecture diagram. So here you can see this is the Cloud Kitchen repository. So you can directly come down and this is the architecture diagram, and let me open this. So for this project, have provisioned the entire infrastructure on Google Cloud Platform using Terraform, and the application is containerized using Docker and deployed on Google Kubernetes engine using a single Helm chart, guys. Okay. And for CI/CD, I have implemented GitHub Actions for continuous integration and ArgoCD for GitOps based continuous delivery. Every code changes automatically triggers the pipeline, builds Docker images, scans them for vulnerabilities using Trivy, updates the Kubernetes manifests, and deploys the latest version of the cluster through ArgoCD, guys. Okay. And for observability, I have integrated Prometheus, Grafana, Alert Manager, and Loki. So Prometheus collects metrics, Grafana provides dashboards and visualization, and Alert Manager handles alerts, and Loki is used for centralized log aggregation, guys. Okay. So to secure this application, I have configured Cert Manager with Let's Encrypt, which automatically provisions and renews SSL certificates, guys. Okay. At the end of this project, Cloud Kitchen application, Argo CD dashboard, Prometheus, Grafana, and Alert Manager all are accessible with my custom domain, which is vijaygidu3.in, using secure HTTPS connection with browser trusted SSL certificates, guys. Okay. So now let me show you each and every dashboard. So let me close this architecture diagram. Now let me open this UI. So basically this is our main application UI, and we can able to access with my domain, which is vijaygidu3.in, and with HTTPS connection, guys. Okay. And if I select this, so here you can see connection is secure and this is the certificate. Okay. So similarly, let me open this Argo CD. So this is Argo CD. So let me refresh this entire page. And here you can see we are able to access Argo CD with my domain name slash Argo CD, guys. Okay. And here you can see this connection is secure. So similarly, let me open Grafana. So here you can see this is Grafana, and Grafana we are going to access with my domain slash Grafana, guys. Okay. And here you can see currently we have nearly 10 plus services like auth service, delivery service, menu service, notification service, order service, payment service, restaurant service, and user service. Okay. So for every service, we have individual dashboards, guys. Okay. And here you can see this is the authentication service dashboard. So similarly, if you want to see other dashboards, for example, if you want to see payment service dashboard, you can directly open this payment service dashboard, and you can see all the pods, P95 latency, and request per second, and you can see all the logs which are coming from Loki. You can see everything in real time, guys. Okay. So basically it will work like a real time application. So here you can see logs are generating from Loki. So for every service we have the individual dashboard. So now let me open Prometheus. So here you can see this is Prometheus, and Prometheus also we can able to access with my domain, which is vijaygidu3.in slash Prometheus, and Prometheus is also secure, guys, with HTTPS connection. Okay. So now if you want to see all the connections, you can directly run up and execute. So here you can see all the services are up, guys. Okay. So now let me do one thing. Let me open monitoring and logging.md. Now let me show you all the Cloud Kitchen targets. Let me copy this query and let me run in Prometheus. And here you can see all the pods like restaurant service deployment, auth service deployment, notification service deployment. Everything is up, guys. Payment service, order service, menu service, user service, delivery service. Everything is up. Okay. I'm going to explain you everything in detail in future, guys. Okay. So now let me open Alert Manager. So this is Alert Manager. So alert manager we can able to access with vjgd3.in/alert manager, and this is also secure guys with HTTPS connection. Okay. So all the services are running inside GKE cluster. So let me open this and let me clear the screen. kubectl get nodes -oy, and it is going to display our Kubernetes nodes. So here you can see currently we have only single Kubernetes node guys. Okay. And let me show you the cluster, and this is my Google Cloud Console. And now let me open Kubernetes engine, and here let me open clusters, and here you can see our Kubernetes cluster. So here you can see this is our Kubernetes cluster, which is CloudKitchen dev cluster. Okay. So now let me open this terminal and let me clear this screen and let me run this command helm ls-a. It is going to show all the helm charts from all the namespaces guys. Okay. And here you can see this is the ArgoCD namespace and this is the Traefik namespace. So let's see this later. Before that, let me do kubectl get ns. It is going to display all the namespaces, and currently we are running all the CloudKitchen services inside this CloudKitchen namespace. So now let me run this command kubectl get all -n CloudKitchen, and let me go up. So inside CloudKitchen namespace, it is going to run all 8 Go microservices and a React frontend and two stateful sets, one for Postgres and one for NATS, and 12 plus services and 9 horizontal pod autoscalers. Apart of that, we are also using Postgres, NATS, and Redis. So now let me explain you why we are using Postgres, NATS, and Redis. So Postgres is the durable system of record where every service stores its own tables like users, restaurants, menus, orders, payments, deliveries, and notifications. And Nats JetStream is the asynchronous event bus that lets services react to each other without direct API calls. Example, when order placed, payment plus notification services subscribe and act independently. And Redis is the fast in-memory cache used for sessions tokens and short-lived rate limiting counters that don't need to survive after restart guys. Okay. So here you can see this is the authentication service pod and this is the delivery service pod and this is the front end pod, notification service pod, and this is the NAT pod and this is the notification and order service, payment service, and this is the Postgres pod and Redis restaurant service and user service guys. Okay. And these are all the pods and these are all the services and these are all the deployments and these are all the replica sets and these are the two stateful sets. Okay. So basically for Postgres and NATS, we created as a stateful set guys. Okay. And we have this horizontal pod autoscalers for all the microservices. So now if you want to see stateful sets, you can directly run this command kubectl get sts-n CloudKitchen. So it is going to display two stateful sets, one for NATS and one for Postgres. So now a part of this, we also have ingress routes inside CloudKitchen namespace. So here you can see this is the CloudKitchen ingress route. So now let me run this command kubectl describe ingress route and name of the ingress route. Okay, -n CloudKitchen. So this is the namespace name, and here you can see within the single ingress route we have multiple paths. So here you can see this is the menu service path. So this is the authentication service path and this is the user service and this is the restaurant, order service, payment service, and delivery service, notification service, and front end. Okay. Within the single HTTP route, we are going to pass all the service routes guys. Okay. So now let me do helm ls-a. So it is going to show us all the helm charts in all the namespaces. So now we are running all the Traefik pods inside this Traefik namespace. So now, so here you can see we are running ArgoCD inside its own ArgoCD namespace, and we install this ArgoCD using Helm. Similarly, we install Traefik using Helm base. Okay. So now let me show you all the services inside this ArgoCD namespace. kubectl get all -n ArgoCD. and it is going to display all the pod services, deployment, stateful sets, and the horizontal pod autoscalers for ArgoCD, guys. Okay, and here you can see these are all the pods for ArgoCD, and these are the services for ArgoCD, and these are the deployments, and these are the replica set, and this is the stateful set for ArgoCD, guys. Okay, so now let me show you for Traefik helm ls-a, and similarly we install Traefik in its own namespace called Traefik. So let's wait, and here you can see Helm chart name is Traefik and namespace it's deployed on Traefik namespace, guys. Okay, so now let me show you this kubectl get all -n Traefik, and it is going to display all the pods, services, deployments, stateful sets inside this Traefik namespace. So here you can see these are the two Traefik pods, and we created Traefik service type with load balancer, and this is the external IP. So basically, when we install Traefik, it is going to create a Google Cloud load balancer, and this is the load balancer external IP, and we associated this load balancer IP with this DNS, guys. Okay, so here you can see same IP you can find in a record. So this is my domain, which is vijaygiridhari.in. So I directly integrated with my GoDaddy domain. So now let me open this, and this is the Traefik deployment, and this is the Traefik replica set, guys. Okay, so apart of this we also have monitoring. So let me do kubectl get ns, and we are running all the monitoring stack inside a monitoring namespace. So now let me copy this name. Okay, now kubectl get all -n monitoring. So it is going to display all the pod deployment services, replica sets, and HPA stateful set and everything inside this monitoring namespace. So here you can see this is the alert manager pod, and this is the Prometheus pod, and this is the Grafana pod. Similarly, this is the services for monitoring, and this is the daemon set for monitoring, and these are the deployments, replica sets, and stateful sets, guys. Okay, so you can find all the monitoring stack inside this monitoring namespace, and you can find all the logging resources inside this logging namespace. So now let me do kubectl get all -n logging. So it is going to display all the pods, deployment services, replica sets, and stateful sets inside this logging. So here you can see we are running Loki inside this logging namespace. So here you can see this is the Loki pod, and this is the Promptile pod, and these are the services, and this is the daemon set, and this is the stateful set, guys. Okay, and finally we have set manager. So here you can see this is the set manager namespace. So now let me copy this and kubectl get all -n set manager. So inside this, it is going to run all the pods, deployment services, replica sets for set manager. So this is the set manager pod, and this is the set manager CA injector, and this is the set manager webhook. So this is the set manager service, and this is the set manager webhook service, and this is the deployment for set manager, and this deployment is for CA injector, and this deployment is for webhook. So similarly, these are the replica sets, guys. Okay, so for every service we have individual namespaces, guys. Okay, so I just created this project like a real-time application, guys. Okay, so end of the day we can able to access all the services with my custom domain slash ArgoCD, and here you can see with my custom domain slash Grafana, and with my custom domain slash Prometheus, and with my custom domain slash alert manager, guys. Okay, and we can able to access all the services with HTTPS connection, which is connection is secure, guys. Okay, and this entire application is deployed on Google Kubernetes engine, guys. Okay, so let me show you the GitHub Actions pipeline. So currently for CI, I have currently we are using GitHub Actions, and for CD we are using this ArgoCD, guys. Okay, so now let me open this GitHub repository, and let me select here Actions, and let me open this update values.ml file. So this is the recent job. So let me come down and let me open this. Okay, so using a GitHub Actions pipeline, so we are going to build all the 9 microservices Docker images like authentication service, delivery service, front-end service, menu service, notification service, order service, payment service, restaurant service, and user service. So it is going to build all the services Docker images. Next, it is going to tag these Docker images with the latest tag as well as with the git commit SHA. Next, it is going to scan all the Docker images using for the vulnerabilities. Next, it is going to push all the Docker images to GCP artifact registry, guys. Okay, So if you want to see that GCP artifact registry, so you need to open Google Cloud and artifact registry, and let me open this artifact registry. So we have a dedicated registry called CloudKitchen registry. And let me open this CloudKitchen registry. Inside this, we have individual path for all the microservices, guys. Okay. So now let me show you that. So here you can see this is the authentication service, delivery service, front end, menu, notification, order, payments, restaurant, and user service, guys. Okay. So let me open menu service. So inside menu service, you can see menu service Docker images, guys. Okay. So these are the menu service Docker images. Okay. Next, this is the job 2, which is update GitOps. So in this job, basically it is going to update values in our Helm chat. End of the day, we are going to deploy this Cloud Kitchen application using Helm chat. So you can find this Helm chat inside this directory. So let me come here. Let me close this ArgoCD and let me close this docs. And here you can see Helm. You need to drop down this. And here you can see Cloud Kitchen. So inside templates directory, you can find all the templates for all the microservices, guys. Okay. So these are nearly 54 plus MLs for across all the microservices, guys. Okay. End of the day. So we are going to deploy this Helm chat using this Argo CD, guys. Okay. So here you can see this is the Cloud Kitchen. Let me open this application inside this Argo CD. So here you can see we are going to deploy all the services using that single Helm chat, guys. Okay. So here you can see all the pods are in healthy state, guys. Okay. So I will guide you step by step in next 10 minutes. So now let me open this. So here you can see end of the day, after updating these Docker images, Argo CD will come to action and it is going to deploy our application to our Kubernetes cluster always, guys. Okay. So now let's place some orders from our main UI and let's run some Postgres commands. So here you can see this is our main. So before that, let me open my documentation. You can directly open docs and Postgres hyphen database hyphen guide.md, and let me come down. So now let me run this first query to see all the accounts. So let me run this query. I think currently we have only single account. So here you can see total registered account is 1. So let me go up. I think I just created with my name itself. Okay. So let me run this first query, guys. Okay. And let me open this terminal. Okay. Let me copy this query once again and let me paste it here. And it is going to show the email. So here you can see vijay@gmail.com. So now let me create a new account. You need to directly select your sign up. test@gmail.com. Okay, let me copy this. Let me remove this. So full name, let me provide test and email test@gmail.com and password test@123, guys. Okay, and let me select here sign up. So now just we created an account, right? So now I'm going to rerun that command once again. So earlier it has shown only one account, right? So now I'm going to rerun this command once again. So here you can see it's created a new account called test@gmail.com, guys. Okay. So this is how it is going to work. So now let me provide test@gmail.com and password as test@123 and login. So here you can see we connected to our test account. So now we have multiple cities like Hyderabad, Bangalore, Mumbai, Delhi, Chennai, Pune, and Kolkata. Now let me select here Hyderabad, and from Vijay's Pizza, I'm going to order this BBQ chicken pizza, and let me add this to cart, and let me select here view cart and proceed to checkout. And let's leave this everything. Okay. Okay. It is asking details. Test. Okay. And place order. So here you can see it is confirming the order, and order has been placed, guys. Okay. So currently it's on the way. Okay. So this will work really like a real-time application, but again this is not the real-time application. I created this project only for the learning purpose, guys. Okay. But anyone can learn using this project. Okay. So now I'm going to select here logout. Okay, so this is how you can place orders. So we have multiple Postgres commands for every service. So this is the auth service credentials and this is the user service credentials. So currently, if you want to see all the profiles, you can directly copy this and you can directly, okay, let me do one thing. Let me copy that query once again. Okay, so it is going to show us all the profiles. Okay, so currently we have only two profiles. So this is how it is going to display this. Okay, and if you want to see for restaurant service, so you can directly run this Postgres commands, and for menu service, so these are the Postgres commands. So if you want to see all the categories, you can directly run these queries. Okay, so in future, like in next 30 to 40 minutes, I'm going to run all these queries and I'm going to explain you in detail, guys. Okay, so if you want to see every order, you can directly run this query. So let me run this query finally. Okay, let me copy this query once again. So here you can see total we have three different orders, guys. Okay, so this is how it is going to show us everything. So in future I will explain you all these queries, guys. Okay, so now let me open this ArgoCD dashboard. Okay, and let me select here ArgoCD. Okay, so now let's start deploying this entire project from scratch. Before that, let me destroy this entire project. So I created all these resources using Terraform state list. Okay, let me do ls, okay, gcp hyphen terraform state list. So it is going to show all the created resources. Okay, so we created artifact registry, firewalls, and VPC, and cloud router, cloud net, subnets. A part of GKE cluster, we created all the GCP resources using Terraform, guys. Okay, due to lack of credentials, I haven't created GKE cluster using Terraform, but inside this Terraform scripts, you can find GKE module. Let me close this and let me close this. And here you can see GCP-Terraform and modules, and this is the module for GK. Okay, so basically this module is working fine, so you can directly create GK cluster using this Terraform. But in this video I'm not going to create GK cluster using Terraform, guys. Okay, so now I will destroy all these resources and let's start deploying this entire project from scratch, guys. Okay, so I just destroyed all the resources inside Google Cloud. So now let me open this Kubernetes clusters. So here you can see we don't have even single Kubernetes cluster, as well as we don't have even single cloud storage bucket, and as well as we don't have single artifact registry, guys. Okay, so now let me open this repository. So now let's start implementing this entire project from scratch. Before we begin, we have already prepared detailed documentation for every phase of this project, and you can find all the documentations inside this docs and GCP directory. And let me open this GCP directory. So I highly recommend reviewing these documentations first to get a complete understanding of this project architecture and deployment workflow, guys. Okay. So now let me open this phase one documentation, which is 01 infra and jumpvm.md file. Okay. So in this phase one, we are going to provision the complete Google Cloud infrastructure using Terraform, and all the Terraform code is available inside GCP-Terraform directory, and you can find that directory inside this GitHub repository, guys. Okay, so here you can see this is the directory which is GCP-Terraform. Okay, and this entire code base follows a modular architecture, which makes it reusable, scalable, and easy to maintain. And using these Terraform modules, we will create the Google Cloud resources like a VPC, public and private subnets, firewall rules, cloud routers, cloud net, artifact registry, bastion VM, and Google Kubernetes engine days. Okay, but in this project, we are not going to create GKE cluster using Terraform due to lack of resources. We are going to create it manually, guys. Okay, so without wasting any time, let's switch to terminal and let's start provisioning our GCP infrastructure using Terraform, guys. Okay, so already I have this entire code inside my terminal. So here you can see all the resources was destroyed successfully. So now let me come out from this and let me come out from this. Okay. So here you can see CloudKitchen app. So already I cloned this repository. So initially you need to clone this repository to your local, and let me enter into this directory, and you need to jump onto gcp-terraform directory, guys. Okay, so here you can see gcp-terraform. So inside this directory you can find all the Terraform scripts for this project. Like, let me open this module. Okay, you can find Terraform scripts for artifact registry, bastion, firewall, gke, and vpc. Okay, so in this video I'm not going to create bastion VM because I'm going to directly connect to gke cluster from this ubuntu VM, guys. Okay, so let me open this gcp-terraform directory, gcp-terraform, and let me do ls. Okay, so inside this gcp-terraform directory, inside this provider.tf file, you need to create a cloud storage bucket, and you need to update that name base. Okay, so let me show you that. So you need to open this provider.tf, and inside this you need to create a Google Cloud Storage bucket with any of the name. Okay, but you need to update that name inside this provider.tf guys. Okay, so because we are going to store Terraform state file inside this Google Cloud Storage bucket instead of local. Okay, so in real time we will store Terraform state file inside Google Cloud Storage bucket. In AWS we will store AWS S3 bucket. In Azure we will store in Google Azure Blob Storage. Okay, so we will store this Terraform state file safely, guys. Okay, but in this video I'm going to create with this same name. Okay, but in your case you can create with any of the name, but you need to update that name in provider.tf file. Okay, and let me open this cloud storage, and let me select here create, and you need to provide the name. Okay, let me select here continue, and I'm going with multi-region. Okay, and continue and continue and create. Okay, so I'm going to create with the same name. So bucket has been created successfully, and here you can see right now bucket is empty, no rows to display. Okay, so now let me open the documentation. Let me open GCP and 01 infra and jumpvm.md. So now let me come down. And the second thing is you need to enable all the GCP APIs like compute APIs, container APIs, artifact registry, IAM and IAP, and cloud resource manager and service networking. You need to enable all these GCP APIs here. Okay, so now you need to create GCP IAM service account JSON. Okay, so let me open IAM and IAM and service accounts. So already I have a service account. So here you can see GCP SCA.json. And let me cat this case. Okay, cat GCP SCA.json. So here you can see already I created a JSON service account JSON from Google Cloud. But I will explain you how we can create this service account JSON also. Guys. Okay, so here you can see this is the service account I created earlier for testing this application, guys. Okay, so now I'm going to create this service account. You need to directly select create service account, and let me provide name like project hyphen cloud kitchen hyphen SA stands for service account, guys. Okay, so this is the name I'm going to provide, and let me select here create and continue. Now here you need to select roles. Okay, so directly, so basically we are creating this project for learning purpose, right? So I'm going to select directly basic and owner permissions, but in real time you need to provide specific permissions. For example, right now we are using let me come down. So right now we are using artifact registry, bastion, firewall, gke, and vpc, right? So in real time you need to provide artifact registry administrator, bastion administrator, and firewall and gke and vpc permissions only, guys. Okay, so like you need to select here add another role, and here for example if you want to provide artifact registry, search for artifact registry. Okay, artifact registry. Okay, so you need to search for artifact registry, and here you can see artifact registry repository administrator. Okay, so artifact registry administrator, so you need to directly select this, and you can directly select continue, guys. Okay, But in this video, I'm going to directly provide owner permissions case, okay? Because this is only for learning purpose, okay? So now let me come down and let me select here done. So we created a service account. So here you can see, where is this? Project Cloud Kitchen SA, okay? So this is the service account we created, right? So now if you want to see all the roles which we assigned for the service account, means you need to directly jump onto IAM, and here you can find all the roles, guys, okay? So let me show you that. And this is the service account project Cloud Kitchen SA. So here you can see we just provided owner permissions. So similarly, while I was testing this application, I directly provided owner permissions case, okay? So now you need to download service account JSON. So this is the service account we created, project hyphen Cloud Kitchen SA. So you need to open this service account and directly jump onto keys, and from here you need to select here add key and create new key, and type you need to select as JSON and create, okay? So now it is going to create a service account JSON. So here you can see it is downloaded to my local. Now let me open this file manager and downloads, and here you can see this is the service account JSON file, guys, okay? Let me open this and let me copy this entire service account JSON. Before that, let me do one thing. ls rm hyphen okay rmgcp hyphen sa.json, and again I'm going to create with same file name, guys, okay? vimgcp hyphen sa.json, and let me insert this entire service account data. Let me copy this and let me paste it here, okay? So here you can see type a service account project. So basically this is my project ID, and this is the private key ID, and this is the entire private key, and this is the client email, which is project Cloud Kitchen hyphen SA. So just now we created this service account. So basically this is the client email, and this is the client ID, and this is the authentication URL, and this is the token URL, okay? So using the service account, Terraform is going to create all the GCP resources case, okay? So similarly, we are going to use the same service account for GitHub Actions pipeline, okay? So in GitHub Actions secrets, we are going to store the service account JSON. So after building Docker images, it is going to use the service account JSON to push those images to GCP artifact registry, guys, okay? So I'll explain you that later. So meanwhile, let me select escape and WP, okay? And let me cat this cat GCP service account JSON, okay? So this is the service account JSON. Now the second step is directly run this command pwd. So it is going to display present working directory, okay? So now you need to open this documentation, and you need to run this command, guys, okay? So basically we are going to export Google application credentials with our service account JSON, okay? So you need to copy up to here and directly come here and paste it here, and now copy this path, guys, okay? Inside this path we have our GCP sa.json, okay? So copy this path / GCP sa.json and hit enter, okay? So now it's using our service account JSON as Google application credentials. So now you need to come down. Now what you need to do is you need to enable terraform.tfs with these details. So earlier we created this cloud storage bucket, right? So you need to update this cloud storage bucket in provider.tf file, as I said, okay? So you need to open this provider.tf, and you need to update that name here, guys, okay? Because Terraform will store a state file here, okay? So now let me open this documentation, and now let's directly run this command, okay? So Terraform init, let me open this and Terraform init, okay? So before running Terraform init, let me open this GCS bucket. So let me refresh this, okay? So here you can see currently inside this bucket we don't have a single row to display, guys, okay? So now I am going to run this command Terraform init. So currently it is going to initialize the backend using our service account JSON, and here you can see Terraform init is successful. So now let me refresh this page, guys, okay? And here you can see cloud kitchen directory has been created successfully, and inside this you can see default TF state. Okay, so we are going to store Terraform state file inside this Google Cloud Storage bucket. Okay, so now let me open this documentation and let me do Terraform plan. uh, After that I'm going to apply individual module. As I said, I'm not going to create a GKE as well as bastion. Okay, so I'm going to create a GKE cluster manually, but I'm not going to create this bastion VM. Okay, meaning jump server, because I'm directly connecting to GKE cluster from my local from this terminal guys. Okay, now let me copy this module.vpc and let me do Terraform plan. It is going to display all the resources it is going to create this. Okay, so basically it is going to display all the GKE, VPC, subnet, cloudnet, cloud router, artifact registries and everything. Okay, so here you can see plan 11 to add, meaning it is going to create everything. Let me go up. So from here you can see it is going to create a artifact registry and it is going to create a bastion VM, and next it is going to create firewall rules. Okay, so this is the second firewall rule for SSH and this is the third firewall rule for internal communication, and this is the module for GKE cluster. And now let me come down, and this is the module for GKE node pool, and this is the module for VPC, and this is the module for cloud router, and this is the module for cloud net, and this is the subnet. Okay, so it is going to create approximately 11 resources, but in this video I'm not going to create a GKE cluster as well as bastion using Terraform. Okay, so now let me copy this first command and let me run this command. Okay, so it is going to create a VPC subnets, like public and private subnets, cloud net, cloud router, and firewall rules guys. Okay, so before that let me quickly open VPC network and VPC networks. Okay, and here you can see right now we have only two VPCs, like default VPC as well as test VPC, but we don't have a VPC with name Cloud Kitchen Dev VPC, right? So now it is going to create that. Let me select here S, and it is started creating VPC. It is going to create VPC, public and private subnets, cloud net, cloud router, firewalls. Okay, so let me show you that. I think it is not going to create firewalls. Okay, for firewalls we have a different module. Let me check that first. Okay, okay. So we are going. It is not going to create firewalls. For firewalls, we have some different modules. Okay, so let me come up. Where is this GCP-Terraform directory? Okay, and here you can see this is the module for firewall. Okay, so currently it's creating a VPC module. Let me open this main.tf in the meantime. So here you can see it is going to create a VPC. Next it is going to create subnets, and next it is going to create cloud router and cloud NAT guys. Okay, so let me go back. Let me come down and let me open this. Okay, so it's creating, and here you can see resources 4 has been created successfully. Let me come here and let me refresh this page. So here you can see Cloud Kitchen Dev VPC has been created with one subnet, and let me open this. And this is the VPC. Inside this, it is going to create the subnet. So this is the subnet. Now, a part of this, it is going to create CloudNet. Let me show you that. So this is the CloudNet. So here you can see Cloud Kitchen DevNet, and a part of this, it is going to create a cloud router. So here you can see Cloud Kitchen Dev Router. So this is the router, and it is connected to our Cloud Kitchen Dev VPC guys. Okay. So now let me open VPC network. Okay. Let me apply these firewall rules. Before that, here you can see inside Cloud Kitchen, we don't have even single firewall rule. So firewall rules are 0. So now I'm going to create module firewall. So it is going to create 3 firewall rules guys. One is for SSH and one is for internal communication, and the third firewall. Let's check that firewall rule later guys. Okay. Meanwhile, let me refresh this page. Let me keep it like this. Okay. So currently it is showing 0, right? So within some time it will display 3. So let me select here as, so basically we need to approve this. So okay, one is for SSH and one is for internal communication and one is for health checks, guys. Okay, so we are going to create 3 different firewall rules. So it's in the creating state, and here you can see all the 3 firewall rules has been created successfully. And let me refresh this. So here you can see 3 firewall rules has been created. So if you want to see that firewall rules, you need to open this VPC and firewalls, and here you can see 3 firewall rules has been created successfully. Okay, so now let me open this one. Now I'm going to create artifact registry module. Let me copy this and let me open this tab. Okay, so indirectly search for artifact registry. Okay, so let me refresh this. So here you can see inside this Google Cloud artifact registry, we don't have even single repository, guys. Okay, so now using this module, using this artifact registry module, we are going to create artifact registry. Okay, so let me open that module for you. Let me open this artifact registry and main.tf. So here you can see it is going to create a single artifact registry. So inside this single artifact registry, we are going to store all the services Docker images, guys. Okay, so let me go back. Now let me apply that module. Okay, let me copy that module name once again. Terraform apply hyphen target is equal to module dot artifact registry. Okay, but we can apply all these Terraform scripts in a single command using Terraform apply hyphen hyphen auto hyphen approve. But as I said, I'm not going to create GKE cluster and bastion, right? So that is the reason why I am creating individual modules. Guys. Okay, so here you can see it's created artifact registry. Now let me open this artifact registry and let me refresh this page. And here you can see artifact registry has been created, but inside this artifact registry we don't have even single folder, guys. Okay, so GitHub Actions pipeline will create Docker images and it will push all those Docker images into this artifact registry. So that is phase 3. So I will show you that within next 30 to 40 minutes, guys. Okay, so in the meantime, let me create a GKE cluster. So you can directly navigate to Kubernetes engine. Let me open this in a new tab and directly select here clusters and directly select here create. Now here I'm going to create a standard cluster. So directly select here configure. Now let me provide a cluster name. So let me remove this CloudKitchen dev cluster. Okay, so this is the name I'm going to provide, and location type you need to select zonal, and I'm going to create in US Central 1 areas. Okay, because I created my VPC on US Central 1. Let me select here subnet. So here you can see subnet I created on US Central 1. So for this GKE cluster, I'm going to use this VPC which is created by Terraform, and I'm going to use this subnet which is created by this Terraform, guys. Okay, so that is the reason why I'm going to select here US Central 1A, because my subnet is created under US Central 1. So now let me come down and you can leave these advanced settings, and in networking you need to select the VPC which we created, which is CloudKitchen dev VPC, and it is going to select the subnet. Okay, so now let me come down and you can leave all these details and directly select here node pools and default pool. So you can give this name for the node pool, or else you can directly change this name, that is up to your wish. And I'm going with control plane version which is 1.35.5, and number of nodes, let's go with 3, and I'm going to enable cluster autoscaler, guys. Okay, and let me select minimum nodes is 1 and maximum nodes up to 4. Okay, so it will maintain only single node, guys. Okay, because we are going to create with some high instance type. So now let me come down and you can leave everything by default, and nodes. Okay, so in nodes I'm going to select image type as container optimized OS, which is container D, and when it comes to machine type I'm going to select E2, and here you need to select standard, And this instance type you need to select, guys, okay, which is E2 standard 4. It comes with 4 CPUs and 16 GB of memory, which is 2 cores. Okay, so let me select this. And boot disk type, I'm going to select standard persistent disk, which is default one. And the disk size, you can go with 60 GB, or else you can go with the 30 GB also, guys. Okay, that will be enough. And you can directly leave this networking, security, and metadata. You can leave this all details, guys. Okay, so directly select here create. So now it will take around 5 to 10 minutes to create this GKE cluster. Okay, so I will be back when this GKE cluster is in up and running state, guys. Okay, so here you can see within just 10 minutes cluster has been created successfully. So now let me select here clusters, and here you can see CloudKitchen dev cluster. So this is the cluster, and let me select here nodes, and here you can see this is the default node pool it's created, and it's created with the 3 different nodes, guys. Okay, so but within next 10 to 15 minutes it will scale to one single node, guys. Okay, because right now we don't have even single resources running, right? So it will scale to single node. Okay, so now let's connect to this GKE cluster. Before that, let me open the shell and let me clear the screen and let me do ls. Okay, so with this service account, we are going to connect to our GKE cluster from our local, guys. Okay, so now you need to run this command gcloud auth activate service account hyphen key hyphen file equal to. So here you need to provide your service account JSON. So let me paste it here, and GCP hyphen SCA dot JSON. Okay, so now it is using this GCP service account JSON to authenticate with our Google Cloud. Okay, so here you can see activated service account credentials for this project is. Okay, so basically this is our service account email, which is project hyphen cloud kitchen hyphen SA, guys. Okay, so now let me run this command. Let me open this gcloud project list. So it is going to list all the projects inside this Google Cloud account. Okay, so here you can see currently we have only single project, which is my first project. So if you want to see that project, so here you can see my first project. So currently we have only single project is. Okay, so this command is going to show all the projects inside our Google Cloud is. Okay, so now let me open this. Now we are going to set this project, which is my first project, using this command gcloud config set project, and you need to provide the project ID guys. Okay, let me remove this. Let me copy this command once again, paste it here, and you need to provide your project ID or project name. Anything is no problem. So this is the project ID. Let me copy this project ID and let me paste it here. Okay, so it is going to connect to this project guys. Okay, next let me copy this command gcloud config get values project. It is going to show the project guys. Okay, so here you can see updated property. Okay, so it's connected to this project. So now let me run this command. So here you can see it is showing this same project ID, meaning it's connected to this project. So now to connect to this GKE cluster, you need to open your Kubernetes cluster. So basically this is our Kubernetes cluster. You need to open this and directly select your connect button. Okay, directly copy this CLI command and open your terminal and directly paste it here guys. Okay, so now automatically it will connect to our GKE cluster. So here you can see kubeconfig entry generated for CloudKitchen dev cluster. Okay, when it's connected to this cluster. Now let me do kubectl get nodes hyphen -y. Okay, and here you can see we have 2 nodes now. Okay, so earlier it has shown 3 different nodes, but it has scaled to 2 nodes. Now within next 3 to 5 minutes it will scale to single node guys. Okay, so I will show you that. In the meantime, if you want to connect using this Google Cloud Shell, you can directly run this command, run in Cloud Shell. So automatically it will connect to this Kubernetes cluster using Google Cloud Shell guys. So instead of local, so this is the second approach. So the third approach is if you want to connect using bastion. So already we have Terraform scripts for bastion. So you need to let me open this. Okay, let me open this. So you need to run this command terraform apply hyphen target equal to module.bastion. So it is going to create a virtual machine inside Google Cloud. Next, what you need to do, you need to connect to that virtual machine and you need to install all these tools, like you need to update and you need to install CSS and you need to install kubectl and you need to install Helm and you need to install JQ, and next you need to check the versions case. Okay, next you can directly connect to that cluster from that virtual machine. Okay, so all the commands are available here itself. Now let me open this. Okay, let me show you the nodes. Let me select here cluster. Where is this? Okay, let me close this and let me select here nodes, and here you can see it scaled to 2 nodes. Now within some time it will scale to single node guys. Okay, so let me check all the pods are in running state or not in the kube system namespace. kubectl get pods -a. It is going to display all the pods from all the namespaces case. Okay, so here you can see all the pods are running from last 15 minutes in the kube system namespace, gmp system namespace, gke manager cm namespace case. Okay, so now let me open our GitHub repository. So 01 infra and jump vm.md, meaning module 1 is completed successfully. We have all the setup inside our Google Cloud Console, meaning all the resources are running fine. So now the second module is 02, which is Traefik Ingress.md. Basically, this is phase 2. So now in phase 2, we are going to install and configure the Traefik Ingress controller on our GKE cluster. So you can follow this 02 Traefik-ingress.md file. So now let me give you a small overview on what actually Traefik is. So basically Traefik is a modern cloud native edge router and it is the single front door of our cluster, and every request from the internet, whether it's for our app or ArgoCD, Prometheus or Grafana, lands on this Traefik first, and Traefik decides which internal service to forward it based on URL path case. Okay, so now without wasting any time, let's start installing this Traefik Ingress controller using Helm. So let me jump on to step 1. So here you can see this is the step 1. So first we are going to add official Traefik Helm chart repository to our local, and next we will update it. After that we will run a single Helm install command with all the configuration flags. All these flags tells Helm to deploy Traefik into Traefik namespace with the 2 replicas and expose on port 80 and 443 guys. Okay, on load balancer service, and it also enables dashboard and makes Traefik the default ingress class for the cluster. So basically this installation will take around 60 seconds guys. Okay, before installing this, let me check whether this Traefik repository is available in my local or not. Previously, while I was testing this project, I just cloned multiple Helm repositories. So let me do Helm repo ls, and here you can see we have Traefik and Argo. So now let me remove this Helm repo remove Traefik. Now it is going to remove this Traefik Helm repository. Now similarly, let me remove this Argo CD guys, okay, which is Argo. Now Helm ls, okay, Helm repo ls. So now we don't have a single Helm repository. Now let me open this. Okay, I'm going to run this command. So initially it is going to add this repository, and next it is going to update this repository, and it is going to install this Helm chart. Okay guys, now let me copy this and let me paste it here. So before running this command, let me open load balancing. Okay, load balancing. So Traefik is going to create a load balancer in our Google Cloud. So basically this will be the entry point of our Kubernetes cluster guys. Okay. So here you can see right now we don't have even single load balancer, right? So now let me select here, enter. So now it will take around 60 seconds to complete this case. Okay. In the meantime, in the background now it is going to create a load balancer guys. Okay. So Traefik will create a load balancer. So here you can see Traefik has been installed successfully, and here you can see update complete, and the name is Traefik, class deployed on the state, namespace is Traefik, status is deployed, revision is 1 and test tools is none. Okay, so now let me open Google Cloud, and this is the load balancing service, and let me refresh this. Okay, so here you can see, as I said, it's created a load balancer, guys. Okay, because let me open this terminal, because we created this traffic with service type load balancer, guys. Okay, so instead of cluster IP, so now for all the services like for ArgoCD, for Prometheus, Grafana, Alert Manager, and for our CloudKitchen, Helm Chat, so we are going to use this traffic ingress controller, guys. Okay, so basically this will act as a front door for all the services which are running inside this GKE cluster. Okay, so now let me open this documentation and let's directly jump on to step 2. So basically in step 2 we are going to verify traffic helm chart and pods and services and CRDs in traffic namespace. So now let me run all these commands, guys. Okay, so now first let's verify traffic Helm chart. So you can directly run this command helm ls-a. It is going to display all the helm charts from all the namespaces, guys. Okay. So currently we install traffic inside this traffic namespace, right? So if you want this only traffic helm chart, you can directly run this command helm ls-n traffic. It is going to display only the Helm chart in traffic namespace, guys. Okay, so here you can see this is the namespace. Okay, so now let's check all the pods. kubectl get pods hyphen n traffic. It is going to display all the pods. So here you can see we have two different pods and it's running from last 4 minutes, guys. Okay, and now let's check the service kubectl get service hyphen and traffic, and we created this service with type load balancer. Okay, so this is the cluster IP and this is the external IP. Okay, external IP in the sense, so this is the load balancer IP address, which is 136.119.163.255, right? So now let me open this load balancing, and here you can see 136.119.163.255, guys. Okay, so same IP address it is showing there. Now, if you want to see all the resources inside this traffic namespace, like all the pods, deployment services, replica sets, HPA, stateful sets, and everything, you can directly run this command kubectl get all hyphen n and traffic. Okay, hyphen n stands for namespace, and this is the name of the namespace. Okay, so these are the pods, and this is the service, and this is the deployment, and this is the replica set for traffic, guys. Okay, so a part of this, let me show you CRDs. Okay, let me run this command. Okay, it is going to display CRDs for traffic. So here you can see these are all the custom resource definitions. So now let me open this documentation. Now let's save this load balancer IP address, guys. Okay, for now, because in future we are going to reserve this IP address, meaning in the same module and the final step we are going to reserve this IP address. So for that reason, let me save this IP address, and here you can see traffic IP address. We just saved this case. Okay, so now let me open this step 3. So basically this is step 3. So step 3 is optional again. So in this step we will send a simple HTTP request to our new load balancer IP, confirm that traffic is reachable or not. At this point, no application routes have been configured yet, right? So traffic will respond with a 404 not found, okay? And this is exactly what we want, guys. Okay? So now let me show you that. Let me copy this and let me paste it here. And here you can see expected output is 404. So because we are not running even single application, guys, okay, inside this GKE cluster. So now let me directly jump on to step 4. So again, this step 4 is optional. So basically traffic comes with the built-in web dashboard that visually shows all the route services and middleware configuration in the cluster. And this is extremely helpful for debugging. You can instantly see which ingress route is handling which path, and view live request count and troubleshoot 404 errors without digging through kubectl output, guys. Okay, and again step 4 is optional, guys. Okay, now let's directly jump on to step 5. So basically step 5 is very important, guys. Okay, so in step 5 we are going to reserve the traffic load balancer IP as a static IP address. Okay, so by default the IP that GCP assigns to our traffic load balancer is ephemeral, which means it can change if the service is ever deleted or recreated. And to prevent that, we will reserve the IP as a static address. So it never change if we even tear down and rebuild our cluster later, guys. Okay. So this step is critical because in phase 5 we will create DNS a record at GoDaddy pointing to our domain to this IP address. And if the IP keeps changing, our DNS will stale the application, guys. Okay. This will become unreachable. So now we will first capture the current IP that traffic is using. And next we will reserve the exact IP as static address in GCP using 𝐺cloud compute address create command with hyphen hyphen address flag. And finally, let's upgrade the traffic helm chart to pin its service to the static IP, guys. Okay. So these are the commands we need to run. So first, let's grab the IP address of traffic load balancer. Let me clear the screen and yeah, let me copy this once again. Okay, copy and paste. Okay. So it is going to grab this IP address. So basically this is our traffic load balance IP address. So now we are going to create a static IP address using that same IP. Okay, let me copy that command once again. Let me copy this and let me paste it here. Okay. So here you need to update project ID. Okay. Simply remove this and open Google Cloud and copy this project ID, paste it here. Okay, hit enter. So now it is going to create IP address with this name traffic load balance IP. Okay, so I think I have reserved that IP address. Okay, so I forgot to delete existing IP address, guys. Okay, while I was testing, I just reserved that old IP address. So I forgot to delete that. Let me delete that IP address first. Okay. Sorry, you need to jump on to VPC and IP addresses. Okay. So here, so basically this is my old IP address, guys. Okay. So let me delete this while I was testing this project. So this is my old IP address. Let me release this and release. Okay. So now we don't have that. Let me run that command once again. So now it is going to reserve this load balance IP address with this name, guys, which is traffic load balance IP. So I think it was resolved successfully. So here you can see traffic load balance IP. So 136.119.163.255. So let me check here. 136.119.163.255. Okay, so it's created successfully. Now let me open this documentation. So if you want to verify using this 𝐺cloud CLI command, so you can directly run this command, guys. Okay, so it is going to show you that. So here you can see traffic load balance IP. So this is the IP. It's in use. Okay. So now we need to upgrade our Helm chart with this new IP address, guys. Okay. So let me upgrade this Helm chart. Let me copy this once again. Paste it here. So now it is going to upgrade this Helm chart with this load balance IP, guys. Okay, so from now it is going to use this load balancer, and again we are going to map this same IP address in GoDaddy a record, guys. Okay, so let's wait for some time. And here you can see it's completed successfully. That means Helm upgrade has been completed successfully. So name is traffic, class deployed on the state, and namespace it's upgraded on traffic, status is deployed, and currently revision is 2. So earlier revision is 1, now revision is 2, guys. Okay, so now let me do helm ls-a. It is going to display all the helm charts. So currently we have only single helm chart, guys. Okay, so here you can see earlier revision is 1 and after upgrade so revision is 2, guys. Okay, so now let me open this documentation and this is completed, guys. Okay, so successfully we have implemented phase 2, meaning we successfully installed traffic ingress controller on our GKE cluster. So basically this is phase 2. So now let's directly jump on to phase 3, which is GitHub Actions CI/CD. Okay, now in phase 3 we are going to configure GitHub Actions CI pipeline to build all 9 of our microservices Docker images and scans them for security vulnerabilities using Traefik and push them to Google Cloud Artifact Registry, and finally commit the new image tags back into our Helm chart so that ArgoCD can deploy them in the next phase, guys. Okay, so now we are going to skip step 1 and 2. So let me show you that. So we are going to skip step 1 and 2 because we already have this entire code in the GitHub repository, and we can skip this step 1, and let me come to step 2. So already we have a dedicated service account. So we are going to skip this step 2 also, guys. Okay. So already, so here let me do less. Okay. So here you can see GCP-SA cat GCP-SA. So already we have a dedicated service account. So that is the reason why we are going to skip this step 2, guys. Okay. So now in step 3, we are going to configure GitHub secrets and variables. So in secrets, we are going to update GCP service account and the GitHub personal access token. And in variable step, we are going to update GCP project ID, GCP region, and GCP artifact registry URL, guys. Okay. So now let's update this everything. So you need to open GitHub. So let me open the repository. Okay, so let me open the repository and directly jump on to settings. And here you need to select secrets and variables and actions. And here you can see you need to create a new repository secret, and you need to keep this as a name, guys. Okay, GCP SA key. So already while I was testing, I just updated this, but value you need to provide your service account JSON, guys. Okay, so in my case, this is my service account JSON. Let me copy this, paste it here. Okay, so this is my service account JSON. Let me check the email, project hyphen cloud kitchen hyphen SA. So this is my client email. Okay, so now I'm going to update this secret. Okay, let me use this GitHub mobile. Okay, so I just approved that. So here you can see I just updated that service account JSON. So now, so the second one is variables. So you can directly jump on to variables tab, and here you need to update artifact repository URL and GCP project ID and GCP region, guys. Okay, so artifact repository URL. So basically this is my artifact registry name. So here let me open artifact registry. Okay, let me select my project. Okay, so here you can see this is the artifact registry name. So you need to provide that same name here, guys. Okay, so you can directly copy this name, and in GitHub variables you need to update this value, and name you need to provide AR repo, guys. Okay, so similarly same names we are passing on GitHub actions pipelines, guys. Okay, so now I'm going to update this. Similarly, you need to update GCP project ID. So basically this is my GCP project ID. So you can directly get this GCP project ID from here, as I said earlier. So you need to open your Google Cloud Console and directly select this, and this is my project, and copy this project ID and just replace it here, guys. Okay, so this is my project ID and update variable. So name you need to provide GCP project id, and for GCP region you need to update this same region, which is US central one. Okay, because we deployed everything like GK cluster, VPC, subnets, everything we created on US central one region, guys. Okay, so similarly you need to provide here US central one and update variable. Okay, so everything you can find in this tab, guys. Okay, so simply what you need to do, you need to update your service account JSON, and just you need to update your project ID. That's it, and you need to keep these values for these variables as it is, guys. Okay, so now let me open this. So all the three has been updated, and in secrets, so our GCP service account also has been updated successfully. So now let me open this step 4. Now in step 4, we are going to allow the workflow to push back to the repository. So by default, GitHub Actions can read the repository content but cannot push commits, guys. Okay, our update GitOps job needs to commit the updated images tags back to the main. So we will go to settings, and next we will go to actions, and next we will go to general and workflows, and we need to set this read and write, guys. Okay, so now let's do this. You need to jump on to settings, actions, and general. Okay, so this is settings, and you need to select actions and general, and here you need to jump onto workflow permissions guys. Okay, so here we can see in workflow permissions you need to select a read and write. Okay, so already I just kept this read and write. Why we are keeping means after building and pushing these Docker images, we are going to update image tags on Helm chart guys. Okay, so let me show you that. Let me open this Helm and CloudKitchen, and you can directly open this values.ml, and let me show you the commit history. Okay, so let me show you the latest one. So here you can see always it is going to update with the GitHub share, right? So that is the reason why we are going to keep workflow permissions as read and as well as write guys. Okay, so that every time GitHub Actions pipeline can update this tags for all the microservices Docker images. Here you can see this is the user service and restaurant service and menu service, order service, payment service. For every service, it is going to update this GitHub SHA-IDs case. Okay. So now let me come out from this. Okay. So it's completed. Now in step 5, we are going to trigger the first pipeline by making a small commit to any service directory or GitHub Actions pipeline, and then the workflow will automatically pick up because of path filters guys. Okay, so we will see that in a moment. So now let me explain you about our GitHub Actions pipeline, how actually it is going to work. So the complete pipeline lives inside .github/workflows directory. So let me open that. So let me open here guys. Okay, so .github/workflows, and here you need to open this cigcp.ml. Okay, ci.ml is for AWS. So again, if you want to deploy this entire project on AWS, so you can directly follow this pipeline guys. Okay, but haven't tested this pipeline, so if you want the same project on AWS, please let me know guys. Okay, so that I can create the same project on AWS also. So for now let's focus on GCP. So you need to open this cigcp.ml. So basically it's a single file with two jobs, one for build and second for update GitOps. So now let's walk through this entire GitHub Actions pipeline. Yes, okay. So as I said, this pipeline runs on two events. First, on every push to the main, when file changes inside any of the 9 service directories or inside Helm chart, that means CloudKitchen Helm chart. Second, on every pull request that changes those same paths. So pull request build and scans images as a safety net, but they do not push the images to artifact registry guys. Okay, only pushes to the main, that is going to push to the artifact registry. Okay, and there is also a concurrency block. So here you can see, so basically, this is the concurrency block that automatically cancels older runs if you push twice in a row. So you don't burn CI minutes or outdated builds, guys. Okay. So let me cancel this. So now let me explain you about this job one. So basically, this is the job one. So before explaining this job one, so here you can see these are all the env variables we are going to use. So we are going to get this project ID, artifact, GCP region, artifact repository, and this host, artifact registry, host, and everything from variables case. Okay, as well as from secrets, we are going to get our service account JSON. First, let me explain you about this job one. So basically, this is a heavy lifting job. It uses matrix strategy to run 9 parallel copies of itself and one per service, like for authentication service, user service, restaurant service, menu service, order service, and payment service, and front end service. Okay, because they run in parallel, and that total build time is only as long as the slowest single service case. Okay, so each matrix instance goes through 9 services. So first let me explain you about this step 1. So in step 1 it is going to check out the repository, meaning it is going to pull our code into the runner. So this is the step 2. So in this step 2, it takes the first 7 characters of the commit shard, and this becomes our image tag guys. Okay, so in the third step, using our GCP service account JSON file, it will connect to our Google Cloud, and this service account is going to fetch from GitHub secrets guys. Okay, so in step 4, it is going to install gcloud in the runner. So in the step 5, it is going to run gcloud auth configure docker, meaning it is going to run this command. So Docker knows how to authenticate when pushing guys. Okay. So now in step 6, basically this is the Docker buildx. It is going to enable advanced features like layer caching across CI runners guys. Okay. And in step 7, It actually runs Docker build on services Docker files and loads the images into the runner Docker daemon, guys. Okay. And in step 6, Trivy is going to scan all our Docker images for high-end critical vulnerabilities, guys. Okay. So now in step 9, it is going to push all the Docker images to GCP artifact registry, like with SHA-ID, guys. Okay. With also latest tag. Okay. So I will show you that later after while building this Docker image. Now the second job is update GitOps. So here you can see this is the update GitOps. So let me cancel this. Okay. So this job only runs after 9 build jobs succeed and only on pushes to the main, and it is the bridge between CI and CD, and its a single purpose is to update our Helm chart with new image tag so that ArgoCD will deploy the new images, guys. Okay. So here you can see in step 1, it is going to check out the repository with a token that allowed pushing baggage. Okay. So, and in step 2, it is going to compute the same short SHA that builds job used. And in step 3, it is going to install YQ, and it's a lightweight ML editor for command line, guys. Okay. So now let's come down. And in step 4, it is going to patch each service strings in Helm Cloud Kitchen values.ml file. So basically this script loops all 9 services, guys. Okay. And it is going to update all the tags in Helm values.ml file. And finally, in the step 5, it is going to commit and push the changes back to the main as a bot user called CloudKitchen CI bot with a commit message tag CI bot bump image tags, guys. Okay. So now let's trigger this pipeline and let's see this everything in live. For that, let's do one thing. Let me update Helm chart, guys. Okay. So you can directly update any of the microservice, like you can update auth, user, restaurant, menu, order, payment, delivery, notification, front end. You can update any of the microservice, as well as you can update Helm chart, as well as you can update this CI/GCP.ml pipeline, guys. Okay. So if you update any of these, this pipeline is going to trigger. Okay. So now I will do one thing, like let me open Helm chart. Okay, so I'm going to modify this Helm chart. Okay, so when we modify this Helm chart, automatically this pipeline will trigger because we updated this path, guys. Okay, that means we updated this Helm chart path here. Okay, in the pipeline. Okay, now let me open this values.ml. So in values.ml, we need to pass this load balancer IP address, guys. Okay, so this is my old load balancer IP address while I was testing. This is my old IP address. So now let me update new IP address kubectl get service -n traffic, and let me copy this external IP. Okay, copy this, and I'm going to update this, guys. Okay, automatically pipeline will trigger, guys. Okay, and this is my old IP and this is my new traffic load balancer IP address, guys. Okay, and commit and commit changes. Okay, changes has been completed successfully. Let me open this actions and update values.ml. So here you can see it started building all the services Docker images, guys. Okay. So let me keep like this. So currently it is going to build all the services Docker images, and it is going to tag with latest tag as well as with the GitHub SHA. Next, it is going to push this Docker image to GCP artifact registry. Next, this is job 2, which is update GitOps. So in this job, it is going to update those image tags in Helm values.ml file, guys. Okay. Before that, let me open this artifact registry and let me open this repository. And inside this repository, right now we don't have even single Docker image, guys. Okay, so here you can see we don't have even single Docker image for any of the microservice. So now let's see this pipeline in live. You can open any of the service, guys. Okay, so here you can see I just opened this build service. Currently it is building this Docker image, and here you can see it's configured gcloud and it's successfully authenticated with my Google Cloud account. It's configured gcloud and it's configured, that means it is authenticated with my GCP artifact registry. Trivy scan image is completed, and this is the report, guys. Okay, so currently it is having total 16 high critical vulnerabilities, guys. Okay, it started building Docker image and also it pushed this image to artifact registry. So here you can see most of the images were completed. Let me go back. Okay. So here you can see update GitOps also started. Let me open this, and here you can see it's completed, guys. Okay. So let's wait and let's see. So job is completed, but still it is loading. But anyhow, let me refresh this page. Okay. It will update, guys. Okay. Meanwhile, let me open this artifact registry and let me refresh this. Okay. So inside this we need to see all the services docker images. So here you can see just now it's updated. Okay, last 1 minute ago and updated just now. Auth service, delivery, front end menu, notification, order, payment, restaurant, user. Let's open authentication service, and inside this now we need to see docker images. So here you can see basically this is the image, guys. Okay, with the latest SHA 3BD C1C0. Now same tag we need to see in other services also. For now, let's open some other service docker image. For example, let's open front end, guys. Okay, we need to see that same tag. So here you can see same tag we can see here also. Now this same tag, it will be updated on helm values.ml file, guys. Okay, so here you can see pipeline is showing green, and here you can see in the stage 2 it installed YQ. So next it has updated this helm cloud kitchen values.ml. So here you can see same tag, guys, for all the services, bqd c1c0 for all the services. So now let's verify this. So here you can see this is the cloud kitchen authentication service, user service, restaurant, menu, order, payment, delivery, and notification, and front end, guys. Okay, all it's updated, guys. All the tags are updated. So now let me check in the Helm chart. Let's come down. Where is this Helm? Let me close this top. Okay, Helm and values.ml. And here you can see it's updated 2 minutes ago, guys. Let me check the history, and let me open this. This is last 2 minutes ago one. And here you can see it's updated with new V3BD C1C0. Okay, same tag. So this is how job 2 is going to work, guys. Okay, so I just explained similarly like a real-time approach, guys. Okay, in real time they will follow the same approach, guys. Okay, so now let me go back and let me open artifact registry, and from CI everything is completed, right? So again, if you want to retrigger this pipeline, you can directly rerun this job. This is the latest job, right? So you can directly rerun all the jobs, or else try to edit any of the changes in .github pipeline. That means CI/GCP.ml pipeline, or in any of the microservice, or in any of the Helm chart. Try to do any changes so that automatically this pipeline is going to trigger, guys. Okay, so basically this is CI, and CD will be handled by ArgoCD, guys. Okay, so now let me select here Cloud Kitchen app and directly go to docs and GCP, and here you can see GitHub Actions is also completed successfully. So now we need to jump on to 04 argocd-deploy.md file, guys. Okay, now in phase 4 we are going to install ArgoCD on our GKE cluster and connect it to our GitHub repository. And ArgoCD is nothing but it's the controller that runs inside the cluster, watches our Cloud Kitchen Helm chart, and automatically applies any changes. So every code pushes to the main, ends up running in the cluster with zero manual steps, guys. Okay, so now let's start setting up ArgoCD on our GKE cluster, and you can follow this 04 argocd-deploy.md file to set up ArgoCD inside GKE cluster, guys. Okay, so now let's come down, and you can directly skip this step 1 because we haven't installed ArgoCD on our GKE cluster. So if you installed manually this Helm chart into this GKE cluster, try to uninstall that Helm chart, guys. Okay, so for that reason I just updated this command in the very first step. So now let's directly come down. So this is the step 2. So in step 2 we are going to install ArgoCD using its official Helm chart with the 3 key flags like service.type equal to cluster IP. So we don't provision a second load balancer, and service.insecure equal to true. So traffic will handle TLS later, and server.root path equal to /argocd. So the UI works under a subpath, guys. Okay. So now let's install this ArgoCD. So before that, let me check whether we have this ArgoCD repository or not. Let me open this and let me clear the screen. 𝐿 and here you can see a part of Traefik. We don't have even single Helm repository, guys. Okay. So now let me copy this and let me paste it here. It is going to add this Helm repository, sorry, ArgoCD repository, and next it is going to install this ArgoCD Helm chart in our GKE cluster, guys. Okay. So it will take around 2 to 3 minutes to install this. So let's wait for some time. So here you can see ArgoCD Helm chart has been installed successfully. So name is ArgoCD last deployed on the state and namespace is ArgoCD status is deployed and revision is 1 and test 2 is none, guys. Okay. So now let me do Helm ls-a. It is going to display all the Helm charts from all the namespaces, guys. Okay. Now, if you want to display only ArgoCD Helm chart, so it's deployed on namespace ArgoCD, right? Helm ls-l ArgoCD. It is going to display only ArgoCD names, ArgoCD Helm chart case. Okay. So here you can see this is how it is going to display and this is the command. Now let's check all the pod services deployments and everything for ArgoCD. So you can directly run kubectl get pods hyphen and ArgoCD. It is going to display all the pods inside ArgoCD namespace. So here you can see from last 1.5 minutes all the pods are running. And let me do kubectl get all hyphen and ArgoCD. It is going to display all the pods, deployment services, replica set, stateful set, and everything for this ArgoCD, guys. Okay. And here you can see all the pods for ArgoCD are in running state and all the services are in um, created with type cluster IP. And here you can see now what we need to do, we need to expose this ArgoCD server with IngressRoute guys. Okay, let's do that later. And these are the deployment and these are the replica set and this is the stateful set case. Okay, so now let me open documentation and it's installed and we also verified. Now, in step 3, we are going to expose ArgoCD via Traefik. So we will apply a small ingress route that routes hitting at slash ArgoCD on our existing traffic load balancer to the internal ArgoCD service case. Okay. So we will then open in the UI in a browser and read the initial admin password from Kubernetes secret and then log in. And next we are going to immediately rotate the password to something stronger, guys. Okay. So now let's apply this ingress ML, that means ingress route for ArgoCD. And here you can see when we hit our IP slash ArgoCD, it is going to route to this ArgoCD server, which is running on port 80, guys. Okay, just now I showed you this, right? So here you can see ArgoCD server on port 80. Okay, now let me clear the screen and let me come down. Okay, let me remove this directory rm-rf amls. Okay, sorry, VIM, sorry, dir amls. Okay, I'm going to enter into the amls directory. Now VIM, let me open this documentation. So we are going to create ingress route for Traefik, right? So Traefik hyphen ingress route, okay, dot ml. Let's create like this and just copy this case, okay? Just copy this. Next we need to apply this. I'm going to paste it here. Now I'm going to apply this kubectl apply hyphen f Traefik hyphen ingress route dot ml. So ingress route has been created successfully. kubectl get ingress route hyphen n ArgoCD. Sorry. So we created this ingress route for ArgoCD, right? Not for Traefik. Let me do one thing. No Traefik ingress Traefik instead of ArgoCD. Okay, ArgoCD. Okay, now this is good. Now kubectl get ingressRoute hyphen and traffic. So it's created kubectl describe ingressRoute hyphen. Okay, ArgoCD hyphen n ArgoCD. Okay, and here you can see name is ArgoCD label. That means namespace it's created on ArgoCD. Labels and annotations we haven't provided anything, and API version is this, and kind is ingressRoute. So this is the main thing is okay. Matches slash ArgoCD. Whenever we are accessing with our traffic load balance IP slash ArgoCD, it is going to route to this ArgoCD hyphen server. Okay, and ArgoCD hyphen server is running on port 80. Okay, so let me show you that once again. So here you can see ArgoCD hyphen server, and it is running on port 80, guys. Okay, so now let's open this documentation. Okay, we just described this everything. Now, if you want to verify whether this ingress route is reachable or not, you can directly run this command. Okay, let me remove this and let me copy this command once again and let me paste it here. Okay, and here you can see Argo CD. It is showing HTTP 200, meaning it's working fine, guys. Okay, now let's open Argo CD UI in the browser. Let me copy this. Okay, let me copy it once again. And here you can see now we can able to access Argo CD with this IP address, guys. Okay, sorry, it has copied once again. Let me copy this. Okay, so basically this is our traffic ingress controller load balancer IP address, and we are going to access with slash Argo CD. Now let's try to access this. Let's do one thing. Let me open this incognito window, http colon slash slash. Okay, and continue to site. It is going to open Argo CD dashboard, guys. Okay, so now we need this Argo CD username and password. So for that, again, open this documentation and get initial admin password and just copy this and paste it here. So it is going to show the password. So basically this is the Argo CD password, guys. Okay, and again, if you want everything in a single command like the username and password and everything, you can directly run this command, guys. Okay, so directly copy this and clear the screen and paste it here. Okay, it is going to display the username and password. So here you can see you can able to access Argo CD with this URL. So basically this is our traffic ingress controller load balance sectional IP, and we need to access with slash Argo CD, and the username is admin and the password is this. Okay, now let me open this. So the username is admin and the password is this, and sign in. Okay, so here you can see successfully we connected to Argo CD UI. Now let me open this documentation, and you can basically this is the option 2, which is alternate option, which is port forwarding. So if you want to port forward this Argo CD UI instead of accessing with load balancer IP address, so you can directly port forward using this command, guys. Okay, but in real time we are not going to port forward this. Okay, we'll follow the same approach, and the best thing is after connecting to this Argo CD, try to delete your old password for Argo CD and try to create a new password, guys. Okay, that will be better. So now let's jump on to step 4. So basically in step 4 we need to generate a GitHub personal access token with the repo scope, and we need to store in Kubernetes secrets labeled with argocd.argoproject.io/secret hyphen type equal to repository. Then ArgoCD auto discovers the secret and uses it for HTTPS Git clones, guys. Okay, so already have GitHub personal access token, so I'm going to use the token, guys. Okay, so here you can see this is my GitHub personal access token. So again, if you want to generate this token, you can directly open your GitHub repository. For example, let me open this. You need to jump on to settings. First, you need to open this CloudKitchen and settings. Okay, so you need to select your profile, and here settings, and here developer settings. and personal access tokens and classic, guys. Okay, so from here you need to generate a new token, guys. Okay, so here you need to generate new token, which is classic, and you need to create a token, guys. Okay, so as I said already, I created a token. Let me go back first. Okay, now this is my token, guys. Okay, so let me open this documentation and let me come down, and we need to create a Kubernetes secret with our personal access token. Let me copy this, let me paste it here, and let me go up, guys. Okay, so in the top we need to update our personal access token, guys. Okay, so now let's remove this everything, and this is my personal access token. Paste it here. Now you can hit enter. Now it is going to create a secret, guys. Okay, and after this let's verify this token. Okay, so if you want to check whether your token is valid or not using a quick API probe, you can directly run this command, guys. Okay, so meanwhile, okay, so secret has been created on ArgoCD namespace with name CloudKitchen-repo. So basically in this we are storing our GitHub username with password, guys. Okay, password in the sense our GitHub personal access token. So ArgoCD is going to use this credentials, our GitHub credentials, and it is going to clone our CloudKitchen Helm chart, guys. Okay, for deployment. Now let me do kubectl get secrets hyphen helm ArgoCD. It is going to display the secret, and here you can see CloudKitchen repo, which is CloudKitchen repo, and it's created last 49 seconds ago. Okay, guys. Okay, with around four data fields. One is type is git, and this is our GitHub CloudKitchen Helm repository URL, and this is the username of my GitHub repository, which is vijay and password is this. Okay, basically this is my GitHub personal access token, guys. Okay, and again after completing this project, I'm going to delete this personal access token. Okay, in your case also, after completing your project, try to delete this personal access token in your GitHub, guys. Okay, so now let me open this documentation, and if you want to, as I said, if you want to do a quick API probe, you can directly run this command, guys. Okay, we need to see 200. Okay, meaning our personal access token is working fine. Now let me confirm this secret. So already I think we confirmed this, right? Again, let's confirm this. Copy, paste. Okay, so now it is going to confirm. So here you can see inside the repository we need to see this label argocd.argoproject.io secret type repository. Okay, so this label is mandatory. Okay, so now let me go to step 5. Now, step 5 is very important. So, in step 5, we are going to apply two YAML files from the repository, and the two YAMLs are available inside ArgoCD directly. So, the first one is project.yaml, and the second one is cloudkitchen.yaml. So, project.yaml is nothing but, so basically, it's the security boundary, and the second one, which is app cloudkitchen.yaml. So, basically, it's the actual deployment definition. So when we apply this app cloudkitchen.yaml application, ArgoCD immediately starts cloning the repository, and it renders the Helm chart, and it creates 51 manifests in 90 seconds, guys. Okay, and after that we can see all our 12 pods are in running state, and application shows as Swiggy plus healthy, guys. Okay, so now let me show you this project.yaml and app cloudkitchen.yaml inside this ArgoCD directory, and you can directly drop down this ArgoCD, and here you can see project.yaml. So basically this project.yaml file defines an ArgoCD app project called CloudKitchen, and basically it's a security boundary that restricts with the Git repositories, namespaces, and resource kinds our ArgoCD applications can deploy, and this will be applied first because all applications references it won't sync without it, guys. Okay, so this is about project.yaml. So now let me show you another one, which is app cloudkitchen.yaml. So basically this is our actual Argo CD application we are going to create. So here, what you need to do is you need to update your GitHub repository URL, guys. Okay. So in this case, I just provided directly my GitHub repository URL. But in your case, you need to update your GitHub repository URL. And here you can see target revision. It has using main branch, because in the main branch we have everything, and the path. So currently we are going to deploy our Cloud Kitchen Helm chart, right? So that is the reason why I just provided this path, which is helm/cloud kitchen. So if you want to see that, so here you can see this is the helm/cloud kitchen. So inside this I have helm chat for this cloud kitchen application. So only one thing you need to do is you need to update this repository URL with your actual repository URL is okay. So if you want that repository URL, you can directly connect open this and https. Okay, so directly copy this and update this repository URL here, guys. That's it. Okay, so now let me explain you about this Cloud Kitchen Helm chart. So let me drop down this, or else let me open this values.ml, guys. Okay, and so let me explain you about this Cloud Kitchen Helm chart. So basically, this Cloud Kitchen Helm chart is lives inside this Helm/Cloud Kitchen directory of this repository. And basically, it's an umbrella Helm chart that packages the entire Cloud Kitchen platform into a single deployable unit. So instead of applying dozens of Kubernetes YAML files one by one, ArgoCD renders one chart and creates everything together, guys. Okay, and all the string lives in single values.ml files. Okay, so when ArgoCD applied this Helm chart, so this Helm chart is going to create around 51 Kubernetes resources inside the Cloud Kitchen namespace, like total 9 deployments. And in this, 8 are Go microservices like auth, user, restaurant, menu, order, payment, delivery, and notifications. So these are the 8 Go microservices. And apart of this, it is going to create React front-end service, and also it is going to create one Postgres stateful set, and this is the shared database with 8 schemas and 12 tables, and one NATS Jetstream and a stateful set for asynchronous event bus, and one Redis deployment for caching and sessions, and 12 plus services for internal networking. So pods can reach other by names, and it is going to create 8 config maps plus 9 secrets, and parallelly it is going to create 8 horizontal pod autoscalers for each microservice based on CPU load and everything, guys. Okay, and also it is going to create a single Traefik ingress route for all the services, guys. Okay, so within the single ingress route, we are going to provide all the paths for all the microservices, guys. Okay, so now this is about the helm chart. So now let me open this app cloudkitchen.ml. Okay. So when we apply this app cloudkitchen.ml file, ArgoCD will clone this repository and renders the helm chart with the current values file and applies all resources into GKE cluster automatically, guys. Okay. So now let's apply this app dot which is project.ml as well as app cloudkitchen.ml inside this GKE cluster, guys. Okay. So now let me open this terminal. So before opening this terminal, let me open this 04 argocd deploy.md. I think it's step 5. Okay. So first copy this command. So first we are going to apply this project.ml which is available inside argocd. Let me select cd dot ls. Okay. So from here run this command, guys. Okay. It will enter into this ArgoCD directory and it is going to apply this project.ml. Okay, so it's created successfully. So now let's check this. First, let me open this file which is app project.ml, and let me copy this name, guys. Okay, Cloud Kitchen. Now let me open this terminal, kubectl, get app project Cloud Kitchen. Okay, -n ArgoCD. Okay, now it is going to show our app project. Okay, so there is a small typo, and here you can see this is the app project, guys. Okay, so now let's try to describe this kubectl, or else let me do. describe app project and app project name hyphen and Argus. It is going to display every details guys. Okay, so here you can see cluster resources. We are going to use this everything guys. Okay, so this is inside the app project. So now let's deploy our actual application guys. Okay, so this is the main thing. Let me open ArgoCD deploy.md and let me directly jump on to step 5. And this is the very important step. Like we are going to apply this app cloudkitchen.ml. So currently here you can see kubectl get ns and great cloud. Okay, so currently with name cloud kitchen we don't have a single namespace, right? So when we create this app cloud kitchen.ml, let me parallelly open this app cloud kitchen.ml. So when we apply this application, so ArgoCD is going to clone this repository and it is going to deploy this cloud kitchen helm chart into our GKE cluster guys. Okay, and again it is going to deploy inside this ArgoCD namespace guys. Okay, so here you can see namespace name, sorry, in the cloud kitchen namespace case. Okay, because if you see destination we just provided namespace as cloud kitchen, so it is going to create a namespace called cloud kitchen, and next it is going to deploy our helm chart into this cloud kitchen namespace case. Okay, so here you can see right now we don't have namespace with name cloud kitchen, right? So now I am going to apply that ml 04 and let me copy this second command. Let me paste it here. Okay, so it's created guys. Okay, immediately let me do one thing, kubectl get app cloud kitchen hyphen n argocd. Okay, so here you can see its sync status is synced and currently health status is progressing guys. Okay, let me keep in hyphen watch mode. Let's see this in live. So now let me open ArgoCD UI guys. Okay, so currently it is not showing any application, right? So here you can see it's in the processing state. So currently synced means currently it's connected to our GitHub repository guys. Okay, so here you can see this is our repository URL with our GitHub secret. So inside secret we just updated our username and password, right? So with that secret it has successfully connected to our GitHub repository and it has started deploying our home chat guys. Okay, so all the pods are in dead state. Part of Redis, all the pods are in not running state case. Okay, so first let's debug that issue. Meanwhile, so let me cancel this. Earlier we just ran this command, right? kubectl get ns grep cloud. Now we need to see cloud kitchen namespace. So here you can see it's created last 82 seconds ago. It's created by ArgoCD guys again. Okay, so kubectl get pods hyphen n cloud kitchen. Sorry, again there is a typo. So here you can see all the pods are in image pullback of state guys. Okay, so apart, so NATS is running and Postgres is running and Redis is running. Apart of that, all our services are in image pullback off. Let me copy any single pod name and let's describe this kubectl describe pod name hyphen n cloud kitchen. Okay, and it is going to display all the details. So in events, you can see everything successfully assigned to Cloud Kitchen namespace, authentication service, okay. Pulling image. So basically it is trying to pull this image, failed to pull image, failed to pull image, okay. Okay, error image pullback off. I got that thing. So currently our artifact repository is private one base, okay. So let's do one thing. Let's make it as public, okay. So this is our artifact registry and select this show info panel, and we need to add a principal guys. Okay, add principal, and here all users. Okay, all users, you need to select this and the basic and owner. Okay. So again, if you want to deploy your private Docker images into this Kubernetes cluster, what you need to do, you need to create a GitHub secret with this GCP service account credentials, and next mount that secret to the deployment guys. Okay, so that it can deploy private Docker images. Now I'm going to keep in watch mode, and let's see whether it can able to pull or not. Okay, because right now we just updated our registry as public. Okay, so here you can see policy also has been updated. We need to see now pods will be in the running state case, okay, within some time. Meanwhile, let me check for ArgoCD. So ArgoCD still it's in the processing state case, okay. So now one by one, each and every pod will come to running state case, okay. Because I just modified the repository permissions to public. So here you can see, as I said, slowly each and every pod is coming to running state. Yes, okay. So user service authentication, restaurant delivery, okay, notification menu, front end, all the services are coming to running state case, okay. Because we just updated that repository to public, and let me refresh, okay. So here you can see Argo CD, it is showing the app health is healthy, and currently it's synced with the main branch with our GitHub repository, guys, okay. So in the meantime, let me come here and let me clear the screen, meaning let me cancel this kubectl get pods I can watch, okay. So here you can see authentication pod is in running state, delivery service pod is in running state, front end it is in running state, menu and nats, notification, order, payment, Postgres, Redis, restaurant, user, all the service pods are in running state guys, okay. So now here you can see this is the Argo CD application. So using Argo CD we deployed this application guys, okay. And here you can see this is the authentication service, delivery service, menu service, and let me close this, okay. Notification, order service, payment service, restaurant service, user service, okay. You can see all the services guys, okay. And here you can see this is the main helm chart. These are all the services, and these are all the deployments, and these are all the replica sets, and this is the nats stateful set, okay. And this is the NAT spot, and this is the Postgres stateful set, and this is the Postgres spot, and this is the delivery service HPA authentication service HPA, and these are all the horizontal pod autoscalers guys, okay. And this is the ingress route, and within the single ingress route we just updated all the paths guys, okay. So now let's see all these services inside this GKE cluster. So these are all the pods. Instead of running pods, let me run kubectl get all hyphen and CloudKitchen, and let me deploy pods. Okay, it is going to display all the pods, deployment services, replica sets, stateful sets, horizontal pod autoscalers, and everything. Okay, so here you can see these are all the pods, and these are all the services. This is the authentication service, delivery service, front end service, menu service, nats, notification, order, payments, Postgres, Redis, restaurant, and user service case. Okay, all the services we updated, and these are the deployment, and these are the replica sets, and we have two different stateful sets, one for nats and one for Postgres, and these are the two stateful sets, and these are the 9 horizontal pod autoscalers for every service. And this is the authentication service autoscaler, delivery service autoscaler, front end service autoscaler, menu service autoscaler. Similarly, for all the microservices, we have horizontal pod autoscalers case, okay. And if you want to see HTTP routes, ingress routes hyphen and cloud kitchen, okay. So this is the cloud kitchen ingress route. So within this single ingress route, we just updated all the rules case, okay. kubectl describe ingress route and name of the route hyphen n cloud kitchen. So this is the namespace name. And here you can see within the single ingress route, we just updated all the services like menu service and authentication service and user service, restaurant service, order service, payment service, delivery service, notification service, okay, front end. We just updated all these services within the single ingress route guys. Okay, so if you want to see that file, you can directly open the Helm chart, and here you can see ingress routes.ml. So here you can see ingress route. So within the single ingress route, we just updated all the services. Instead of maintaining 9 ingress routes, I was maintaining all the rules within the single ingress route guys. Okay, and it is going to take load balancer IP from the values.ml file. If you remember, while we are working on GitHub Actions CI/CD pipeline, we just updated this IP address guys. Okay, so it is going to take that IP address from values.ml. Similarly, it is going to take the host also. Okay, so now let me open this documentation 04 ArgoCD, and let me come down. Okay, so now step 5 is also green. Okay, so again step 5b is optional, you can leave this everything. So now let's talk about step 6 guys. Okay, so finally in step 6 we will test this entire loop by making a small change in any service and pushing them to main and watching CI build and images, and it commits the new tags, and Argo CD will roll the pods automatically, and total time from git push to running to new code will take around 2 to 3 minutes guys. Okay, so now let's add a small commit for Docker file or GitHub Actions pipeline, and let's watch these changes guys. Okay, so instead of modifying Docker files, what I will do, I will directly modify this .github slash workflows pipeline. Okay, cigcp.ml. Let's add a small line guys. Okay, I'm going to add like this. Now commit changes. Okay, now this pipeline is going to trigger, and here you can see pipeline is started triggered. Let me come down. So it started building all the services Docker images, and after building Docker images using Trivy, it is going to scan all the Docker images. Next it is going to push two different Docker images, one is with the latest tag and one is with the GitHub SHA to the GCP artifact registry. Next, this update GitOps job will update Helm values file, meaning it is going to update with the Docker image tags case. Okay, next it is going to push those changes to this same GitHub repository to the helm values.ml file case. Okay, once ml file is updated, right, Argo CD will come to action and it will deploy latest images to the GKE cluster guys. Okay, so in the meantime, what I will do, kubectl get pods -n cloud kitchen -watch. Okay, so I just kept this in watch mode because once this pipeline is green, right? Once this pipeline is green, Argo CD will come to action and it will deploy latest pod guys. Okay, I will show you that in live. Meanwhile, let me open artifact registry, and here you can see just now it has pushed all these images. So updated just now. Now let me open. It is building order service. Okay, order service is pending and it's complete. Now GitOps. Okay, so image. Okay, so all the jobs are completed guys. Okay, so here you can see all the images were updated successfully. So now let me check this. Let me jump on to values.ml file, and here you can see just now it has updated. Let me select here history, and here you can see committed now. Let me open this, and here you can see, if you remember, 3PD C1 C0 is our old tag and this is our new tag FC75266. Okay, so let's check in the artifact registry. Let me open any of the service, and the latest one is FC75266 guys. Okay, so now Argo CD will pull these images guys. Okay, so this is how it is going to work guys. Okay, in real time we will follow the same approach. In the meantime, so let me open this Argo CD. Okay, so currently it is showing healthy, and so here you can see these are our old pods, right? So now within some time it is going to deploy our new pods. Meanwhile, let me refresh this, and here you can see it started syncing, meaning it will deploy our latest pod. So here you can see it started deploying all our new pods guys. Okay, so here you can see it started deploying. as I said, because GitHub Actions pipeline has updated those image tags in the Helm chart, right? So that is the reason why ArgoCD has detected those changes and it has deployed those new images to the GKE cluster, guys. Okay. So in real time, it will be the same approach, guys. Okay. So in the meantime, let me cancel this kubectl get pods hyphen and cloud kitchen hyphen watch, and here you can see all the services pods are running with the new images, guys. Okay, so if you want to confirm those images, directly copy any of the service, that means any of the pod name, and describe this pod kubectl describe pod name hyphen and cloud kitchen. So basically this is the namespace name, and let's check for image tag. So here you can see this is the image usntel1-docker.pkg.dev and cloud kitchen repository auth service, and this is the tag fc75266, right? So here you can see new image is fc75266. So same image you can find inside this repository fc75266. Okay, so this is how it is going to work, guys. Okay, so this is the real time approach. Okay, so now finally let's try to access our Cloud Kitchen application externally, guys. Okay. So because all the pods are in running state, kubectl get pods hyphen and Cloud Kitchen. Okay. So all the pods are in running state, right? Anyhow, we just updated our load balance IP in the Helm chart, right? So it has updated those images on the HTTP routes, guys. Okay. So now let's try to copy this Traefik ingress controller load balancer IP address kubectl get services hyphen and traffic, and copy this external IP of traffic. Okay, let me copy this once again. Now let me open new tab, and we are going to access Cloud Kitchen. Okay, so here you can see we can able to access Cloud Kitchen application. So but we don't have even a single restaurant data and everything, guys. Okay, so for that what we need to do, let me go back. Okay, so in this same phase we need to populate demo restaurant catalogs, guys. Okay, so let me run these commands. So basically it is going to seed this data, that means it is going to seed this SQL data into this Postgres database, guys. Okay, so let me paste it here. Immediately we can see all the restaurants and everything else. Okay, so here you can see total 20 restaurants has added, 41 categories is added, 99 menus are added, guys. Okay, in our application. Let me just refresh this, and here you can see we can see everything. So across all cities, these are all the restaurants, and in Hyderabad we have only 4, in Bangalore we have only 4, and Mumbai we have 3, Delhi we have 3, Chennai we have 3, Pune we have 2, Kolkata we have 1. Okay, so now let's test this application later, guys. Okay, let's try to sign up this application later. First, let me open this documentation now. Okay, now our app is fully running on GKE and updated automatically by ArgoCD. And next step is to make it reachable via a custom domain. So in phase 5 is DNS plus GoDaddy. So we will point our custom domain, which is vijay.in domain at traffic load balance static IP address, and we are going to set up DNS. So you can directly follow 05 DNS and godaddy.md5, which is available inside GCP docs and this directory, GCP directory. This is the file, guys. Okay, 05 DNS and godaddy.md. So you can directly follow this documentation, guys. Okay, so let me open this terminal. So this is phase 5, which is DNS plus GoDaddy. So now let me come down. So in very first step, we will read the load balancer IP from the cluster with a single kubectl command. Then log into our GoDaddy account, and we will go to the DNS management page of our domain. And then we will add a new A record with our traffic load balancer IP, guys. Okay. So now let me copy this command, and let me clear the screen, and let me run here, guys. Okay, and here you can see this is our load balancer IP address. Now let me open documentation, and you need to add this case. Okay, so let me open my GoDaddy account. So basically this is my GoDaddy account, guys. Okay, now this is the a record, and I need to edit this, and this is my IP address of traffic load balancer. Okay, and directly select yes, save. So it is updating DNS records. So from now it is going to take around 10 to 20 minutes to update these DNS records. Sometimes it will take more than 1 to 3 hours, guys. Okay, so it depends, guys. Okay, so let me refresh this, and let me open this. Now in step 2, let's verify DNS propagation. So GoDaddy usually takes between as I said 1 to 10 minutes. Sometimes it will take more than 3 hours. So to update a new record to the public resolvers, so we need to verify this with the dig or nslookup command. So both should return our load balance IP address case. Okay, so instead of dig, let's go with nslookup command. NSLOOKUP. So basically this is my domain name, guys. Okay, so here you can see this is my domain name, and I just updated my traffic load balancer IP with a record for my GoDaddy domain vijaygadutari.in. Now let me copy this, paste it here. It should, okay, so DNS has been updated successfully, guys. Okay, so for our sheet, let me open DNS propagation checker. Let me open this first link. Now vijaygadutari.in and a record, and in India it's not updated, but okay, so in most of the countries it's updated successfully, guys. Okay, so now what I will do, I will try to access with my domain name. Before that, one thing you need to do. So now let me do a quick sanity check for my domain, which is vijaygadutari.in. Let me copy this and let me paste it here. And here you can see it is showing status code as 200, meaning it is working. Okay, so in third step we are going to update Helm chart to accept the host names, meaning I already updated this host name in helm values.ml file, guys. Okay, so this is my domain, right? So this is my domain name, so you need to update this domain name on helm values.ml file, guys. Okay, so let me show you that. You need to directly navigate. Let me open this. Okay, let me go up and the CloudKitchen app, and here let me open Helm, and now you need to open this values.ml. So if you remember previously we just updated load balancer IP address, like meaning traffic load balancer IP address, right? So similarly we need to update this host, guys. Okay, so when we update this host, automatically it will take the same host name for all the ingress routes for all the microservices, guys. Okay, so in your case, you need to update this host name, and next you need to trigger this pipeline. Okay, meaning if you update this host name, automatically this pipeline will trigger, and automatically it will redeploy everything, guys. Okay, so already I just updated this host name, right? So let me do some edit for this ML5. I'm just removing this comments. Okay, so in your case, once again, I'm telling you here you need to update your host name, and you need to do commit changes. Okay, now it will start building this pipeline, and here you can see values.ml, and it started building all the services Docker images, and next it will update those Docker images in artifact registry, and as well as it will update those images on helm values.ml file, guys. Okay, after that ArgoCD will come to action, and it will deploy all our services to GKE cluster. Okay, so in the meantime, let me come here and let me do kubectl get pods -n CloudKitchen -watch. Okay, So from last 33 minutes, all the pods are running, right? So once this pipeline is green, so ArgoCD will come to action and it will deploy latest Docker images to our Kubernetes cluster base. Okay. So let's wait for some time. So here you can see all the images were built successfully and pushed to artifact registry. Now it is going to update image tags on helm_values.yaml file guys. Okay. So here you can see update is also completed. So now the new image tag is 2FEC561, right? So first let me check the artifact registry. So let me refresh this. And here you can see it's updated just now. Now let me open this notification service. Inside this we need to see that image tag guys. Okay. So let me check that once again. Let me open the GitHub Actions pipeline and okay, 2FE, right? And let me open artifact registry now. And here you can see 2FEC561. Okay. So now this image will be deployed on our GKE cluster. Okay. It will be deployed using ArgoCD. So similarly, let me check helm_values.yaml file. And this is the values.yaml. And here you can see it's updated 1 minute ago. Let me check the history. And let me open this latest commit. And here you can see 2FE561. Okay. So it's updated for all the microservices for auth, user, restaurant. For every service, it is updated with the new image tags, guys. Okay. That is good. So let me go back. Okay. Now let me open ArgoCD and just let me refresh this case. Okay. And here you can see currently it is started syncing. Now here you can see all the ports are getting restarted with the new images, guys. Okay. So let's wait for some time. So currently its sync is also completed, guys. Okay. So it's completed successfully and all the new pods were deployed and it's in the processing and app healthy is healthy, guys. Okay. Now let's check all the pods. Let me cancel this and kubectl get pods -n CloudKitchen. And here you can see from last 30 seconds, all the pods are in running state, guys. Okay. So now let's check the image stack. Let me copy any of the pod name and kubectl describe pod and pod name -n CloudKitchen. And here you can see this is our image and we need to focus on the tag, guys. Okay. So sorry, this is the image uscental1 -docker.pkgdev. So this is the tag 2FE-C561. Okay. So it has used the same tag. So this is how it will work, guys. Okay. But in your case, you need to update your domain in helm_values.yaml file, guys. Okay. So now let's try to access our application using our domain name. So before that, okay, so you can leave all these commands, guys. Okay. So it is not necessary to update this helm_values.yaml file, meaning it is not necessary to update this ingressroutes.yaml file, because let me give you a small explanation for that. Let me open this templates directory and here let me open ingressroutes.yaml. And here you can see we have only single ingressroutes.yaml with all the microservices paths. And here you can see this is for menu service and this is for auth service and this is for restaurant service, user service, order service, payment service. For every service, we have all routes inside single ingress route file, guys. Okay. And it is going to take traffic load balancer IP from values.yaml file as well as it is going to take host name from values.yaml file. Yes, okay. It is not necessary to update this ingress routes.yaml. Simply you need to update this values.yaml. Let me open this values.yaml. Simply you need to update this values.yaml with your host name as well as with your load balancer IP address. Again, if you don't want to expose this load balancer, it is not necessary to update this load balancer IP address. Okay, you can leave this empty but try to update this host name, guys. Okay. So now let's try to access ArgoCD and our application using our domain name. Let me drop down this. Okay. And let me open http://vijaygidu3.in. Okay. It needs to redirect to my main application. So here you can see I can able to open my Cloud Kitchen application. So similarly, let me open ArgoCD also. http://vijayagirturi.in/argocd. Okay. Now it is going to open ArgoCD dashboard, guys. Okay. And here you can see we can successfully able to open ArgoCD with my domain name /argocd, and I can able to successfully open this Cloud Kitchen with this domain which is vijayagirturi.in, guys. Okay, but here right now it's not secure, but in phase 7, I think. Let me check that. Let me go up. Okay. So in phase 7, we are going to set up HTTPS connection, guys. Okay. After this, now we need to set up monitoring. After monitoring, we are going to set up HTTPS connection, guys. Okay. Now let me open this. End of the day, we can able to access this application with my domain name. And similarly, we are going to able to access ArgoCD with my domain name, guys. Okay. So let me remove this too, because right now we are accessing with this IP site, and we can remove this too. Now let me provide ArgoCD username and password. Before that, if you want this ArgoCD username and password, as I said earlier, you can directly open argocd-deploy.ml, and you can directly come down and directly run this entire command, guys. Okay, copy this and clear the screen and paste it here. That's it, guys. Okay, it is going to display the username and password. So here you can see username is admin and this is the password. So now let me copy this password and let me open ArgoCD UI. So the username is admin and the password is this, and sign in. Okay. And here you can see we can able to see our ArgoCD application, meaning Cloud Kitchen help chat. And let me open this, and here you can see everything is up and running, guys. Okay. And inside our cluster, everything is running. Let me do kubectl get pods -n Cloud Kitchen. Okay. So all the pods are running inside this Cloud Kitchen namespace, and this phase 5 is also completed, guys. Okay, so phase 5 is also completed, DNS and GoDaddy setup. So now we need to focus on this monitoring and logging for our Cloud Kitchen application. Now our application is running fine and accessible via custom domain. And the next step is to add full observability. So we can actually see what's happening inside the cluster, like CPU and memory usage, request rates, error rates, latency, and live logs from every pod, guys. Okay. So in phase 6, we are going to install two well-known observability bundles on our cluster, like Prometheus Tech, which brings Prometheus, Grafana, Alert Manager, Node Exporter, and Kube State Metrics together. And the second one is Loki Stack, which brings Loki for log storage and Promptile for log shipping. Both will be deployed as a new ArgoCD applications, so they can fit cleanly into our GitOps workflow. So all three UIs like Grafana, Prometheus, and Alert Manager will be exposed under the subpaths of our existing domain. So nothing new at the DNS or load balancer level, guys. Okay, just we are going to add three new path-based routing. Okay, so now let's see this everything in live. Now let me open this step 1. So in step 1, we are going to configure the monitoring ArgoCD application. So we are going to open app-monitoring.ml, which is available inside ArgoCD and /apps. And we need to replace its helm.values block with one that tells Grafana to serve from /Grafana with the right root URL and server from subpath equal to true, and Prometheus to serve at /Prometheus using route prefix and external URL, and alert manager to do the same at /alert manager. And we also wire Loki as an additional Grafana data source. So logs panels work out of the box, guys. Okay. So now let me show you this app monitoring.ml. So you can directly drop down this ArgoCD and you can directly open this app, and here app monitoring.ml. So this is the application for monitoring, guys. Okay. So now we are going to apply this monitoring one. But the thing is, you need to update your domain names here. For Grafana, here you can see at line number 71, you need to update with your domain. So this is my domain. I just already updated. And in 72, you need to update your domain. Okay. vijayagirturi.in/Grafana. In your case, your domain name /Grafana. Similarly, for Prometheus, you need to update at line number 107 with your domain name. Okay. Similarly, let me come down. For alert manager, you need to update at line number 134, guys. Okay, with your domain. Okay, so here you can see vijayagirturi.in/alert manager. So in this case, if you are updating this, we can directly access this from it just run and alert manager with our domain names case. Okay. So now let's apply this ML. Let me open this documentation once again, monitoring and logging, and let me come down. So now let me explain you step 2 also. So basically, let me keep like this, guys. Okay. Okay. So now in step 2, we are going to open app logging.ml, which is available inside ArgoCD and /apps. And we are going to add one tiny override like http colon slash slash logging hyphen loki colon 3100 slash loki slash API slash v1 slash push. So this fix a chart naming quickly where promptile defaults pointing at the wrong service name. So without this override, promptile logs floods into no such post error, guys. Okay. So now let's apply this both MLs. So before that, let me show you this app logging.ml. So here you can see this is the application for app logging. Okay. So you need to update this one, guys. Okay. So URL path, but it is not necessary to update. I just already updated this everything, right? So you need to update in app monitoring.ml application, guys, with your domain names as I showed. Okay. So in line number 72 as well as in line number 107 as well as in line number 124, you need to update your domains. That's it, guys. Okay. So now let's apply this app logging.ml as well as app monitoring.ml files application. Sorry. So now let me open this one, app monitoring.ml, and in step 2 we have those two commands, guys. Okay. So kubectl apply hyphen f argocd apps and app monitoring.ml. Similarly, kubectl apply hyphen f apps app logging.ml, guys. Okay. So when we apply this automatically inside ArgoCD, it will start creating both the applications. So here you can see, if I refresh this, let me open applications. Okay. So currently we have only CloudKitchen application, right? So when we apply these two MLs, so when we apply these two applications, automatically it is going to create two different applications, guys. Okay. One is for logging and then one is for monitoring. So now I'm going to apply these two. Okay. And here you can see it's created successfully, right? Now let me open this, and here you can see it's creating for monitoring as well as for logging, guys. Okay. And let me open this, and here you can see it started creating. So it's creating, let me go back, and it's creating on namespace called, let me check the namespace. Okay. Namespace called logging, and similarly other one is creating on monitoring, I guess. Okay. So here you can see it's creating on monitoring namespace and it's creating on logging namespace. Let's check this parallelly. Currently, both are in processing state, guys. Okay. So for monitoring, it is showing degraded, but within 1-2 minutes, it will fix, guys. Okay. It will automatically fix. Okay. So some pods initially it will go to crash loop back of state, but within just 1 minute, automatically it will fix everything, guys. Okay. So that is the common issue. In the meantime, let me open this and the kubectl get ns and kubectl get pods hyphen n. So here you can see login 63 seconds it's created. Monitoring also 62 seconds ago it's created, guys. Okay. So now let me hit login, and here you can see pods are coming to running. So in monitoring it is showing degraded, right? Let me check monitoring hyphen watch. Okay. So all the pods are in running state, guys, in monitoring. Okay. So now let's, okay, so here you can see it is showing healthy and synced, and it's showing healthy. Okay, as I said, it will fix automatically in just 1 or 2 minutes. That's it, guys. Okay, so currently, but this monitoring is in still syncing state, guys. Okay, so let's come down. So all the pods are in running state. Now let's check all the resources inside this, both the namespaces, guys. Okay, kubectl get all hyphen n logging. So here you can see this is the logging namespace pods, and inside logging we have Loki 0 pod and promptile pod. Similarly, this is the Loki service, and this is the Loki headless service, and this is the member list service, and this is the daemon set for promptile, and this is the stateful set for Loki, guys. Okay. So similarly, let me check for monitoring kubectl get all -n monitoring, and here you can see all the pods like alert manager, kube Prometheus operator, Grafana, kube state matrix, and node exporter, and kube Prometheus. Everything is running as okay. So these are all the services, and these are all the pods, and this is the daemon set for node exporter, and these are the deployments, and these are the replica set, and these two are the stateful sets case. Okay. So everything has been created successfully, and we created these two like monitoring stack as well as logging stack using ArgoCD application case. Okay. So now let me open this documentation. So in step 3, we just applied these two MLs and we also verified this, right? So let me show you the apps in CLI also. So if you want to see these applications, if you want to see these applications from the CLI, you can directly run this command guys, okay? It is going to show all the three applications. So this is the CloudKitchen application, logging application, monitoring application guys, okay? So this is how it is going to show us everything. Now let me open this. So basically, step 4 is the sanity check service. So we already verified this monitoring pods and the logging pods and logging services, monitoring services, everything, right? So we can skip this step 4. So now let's directly jump on to step 5. So in step 5, we are going to create Traefik IngressRoute YAML, one for each service like Grafana, Prometheus, and Alert Manager. Each routes the corresponding subpaths on traffic load balancer to the internal service in the monitoring namespace. After applying them, all UIs are accessible from the browser through our domain desk. Okay. So now let me apply these three ingress routes. So this is the ingress route for Grafana, and here you can see host is vijayagiri3.in, and this is my old load balancer IP address case. Okay, traffic load balancer IP address, but it is not necessary to update this IP address case. Okay, but end of the day we need to access with our DNS name, which is vijayagiri3.in. Okay, so now I'm going to apply these three MLs. All the three MLs are available inside monitoring and ingress routes. Let me show you that. You need to drop down this monitoring and ingress routes, and here you can see grafana.ml, alertmanager.ml, and prometheus.ml guys. Okay, now let me copy all these commands, paste it here, and for grafana it's created, prometheus it's created, alert manager it's created. Okay, so here you can see these are the three ingress routes. Okay, so now if you want to describe any ingress route, you can directly run this command qctl describe ingress route, ingress route name -n. Let me check the namespace name. I think it will be on monitoring guys. Okay, so here you can see monitoring, and it is going to display full details guys. Okay, so here you can see name is alert manager. So namespace is deployed on monitoring, and this is the annotation, and namespace is this, and kind is ingress route and created on this time frame, and this is the main thing. So match path host is vijayagiri3.in, and okay, so when we hit vijayagiri3.in/alert manager, it is going to redirect this ingress route to the alert manager service guys in the backend. Similarly for Prometheus, similarly for Grafana also guys. Okay, so let me show you that. Let me select here Grafana, and here you can see we have Grafana as well as Prometheus. So now I'm going to describe this Grafana, and here you can see when we hit vijayagiri3.in/Grafana, behind the hood it will redirect this ingress route to this monitoring Grafana service case. Okay, so similarly if you want to check for Prometheus, you can directly hit here Prometheus case. Okay, and here you can see when you hit vijayagiri3.in/Prometheus, behind the hood this ingress route is going to route to this Prometheus group Prometheus service case, which is running on port 9090. Okay, so now let's try to access this Prometheus Grafana and alert manager dashboards. Let me drop down this. Okay, now http://vijayagiri3.in/grafana dot in slash grafana guys. Okay, let me select here advanced. and proceed. Okay, so it is showing 404 not found. So it will take some time, guys. Okay, so http colon slash slash vijayagiri3.in slash Prometheus. It is going to open Prometheus dashboard. So here you can see we can able to open Prometheus with my domain slash Prometheus. Similarly, let me try to open alert manager, http colon slash slash vijayagiri3.in slash alert manager. And here you can see we can able to open alert manager with my domain slash alert manager, but Prometheus is not coming to up. Let me check this. http colon slash slash vijayagiri3.in slash grafana. Okay. So now it is redirecting traffic to Grafana service case. Okay. So here you can see vijayagiri3.in slash grafana. So here you can see we are on login page of Grafana. So we need username and password, right? So you can directly open this documentation and directly come down and we just update these three MLs. And next, if you want to verify from terminal, you can directly run these commands case. Okay. So we need to see status code as okay. Okay. So here you can see Grafana 200, Prometheus 405 and okay. So now, if you want to access Grafana, you need to open like this http colon slash slash your domain name slash Grafana and Prometheus your domain name slash Prometheus, and for alert manager your domain name slash alert manager case. Okay, and for Grafana this is the username and this is the password case. Okay, from operator. So let me log into Grafana admin and this is the password. Okay, so now we are going to connect to this Grafana and in dashboards. So here you can see in dashboards right now we have only default dashboards, but currently in our project we have multiple microservices, right? Let me do quickctl get pods hyphen and CloudKitchen. So inside CloudKitchen namespace, we have multiple services, right? So now what we are going to do, we are going to create each dashboard per service case. Okay, for auth service, there is an individual dashboard, and for delivery service, there is an individual dashboard, and for front end, there is an individual dashboard, and for menu service, there is an individual dashboard. Similarly, we are going to create individual dashboards for each and every microservice case. Okay, so before that, let me jump on to step 6. So in step 6, we are going to apply service monitor CRDs into the CloudKitchen namespace. So basically it uses a label and a selector like app.kubernetes.io slash part of CloudKitchen that matches all 8 backend services. So Prometheus auto discovers it and starts scraping at slash metrics on each of them guys, okay, for every 30 seconds. So here there is no chart edit needed guys, okay. So you can directly apply this ML, service monitor ML. So let me copy this and this service monitor is available inside monitoring and service monitor. And let me show you that. And here you can see this is monitoring and here you can see service monitor.ml. Okay. So let me copy this and let me paste it here. Okay. Let me copy that once again. Copy and paste. Okay. So first it is going to create this service monitor. Next it is going to show us the service monitor guys. Okay. So kubectl hyphen and CloudKitchen get service monitor. Okay. So this is the service monitor. It's created guys. Okay. So now let me open this documentation. So now if you want to verify the scrap and everything, you can directly run this various guys. Okay. And here you can see status is success. That means it's working fine. You can skip this step 7. So let's directly jump on to step 8. So in step 8, we are going to apply per service dashboard one for each microservices. So basically charts built in dashboards are generic. So to debug a single microservice, we want a focused dashboard with the service request, error rate, and P95 latency, CPU and memory, live logs, and on one screen, right? So we can apply this Cloud Kitchen dashboard ML, which is available inside monitoring and dashboard. And it's a per service generated bundle of 8 config maps, one for each microservice. And Grafana sidecar containers auto loads with them in just 30 seconds case. Okay. So now let me run this. And once again, let me open this. If you want to check this dashboards. You can directly see in monitoring and dashboards. Okay. So here you can see CloudKitchen dashboards.ml. So first we are going to run this generate.py. Next we are going to apply this CloudKitchen.ml guys. Okay. So now let me copy this. Okay. Let me copy that once again. Copy and paste. Okay. Now let me come down. Now I'm going to apply this CloudKitchen dashboard.ml. Let me copy this and let me paste it here. And okay. Now let's verify inside Grafana. Okay. Let me check whether this is applied or not. Okay. Monitoring dashboards. Okay. kubectl apply -f cloud kitchen dashboard.ml. Okay. So now here you can see it's creating guys. Earlier it is not created. If it's created means inside this config map we need to see all the dashboards. So now here you can see config maps has been created for every service. So this is the auth service, user service, restaurant, menu, order, payment, delivery, notification guys. Okay. So now let's verify this. Copy. Okay. Let me copy it once again. Copy this and paste it here. Okay. Now let me go up. Okay, so here you can see these are all the config maps. So this is the auth service dashboard config map, and this is the delivery service dashboard config map, menu service dashboard config map, notification service, order service, payment, restaurant, user. Okay, so these are all the services dashboards, guys. Okay, and now let's check all these dashboards inside Grafana. Let me open this. So in the meantime, if you want to verify in Grafana, you can directly run this case. Okay, first let me run this. Okay, so here you can see it is showing all the dashboards, meaning it is working guys. Let me open this and let's select here dashboards, or else let me refresh this page entirely once again. And here you can see it's created a per service dashboard as I said. So this is the auth service dashboard, and this is the delivery service dashboard, and this is the menu service dashboard, and this is the notification service dashboard, and this is the order service dashboard, and payment service, and restaurant user service. All the dashboards has been created successfully. Now let me open this auth service dashboard and let me keep it for 5 seconds. So this is the last 1 hour data. If you want to check last 15 minutes data, you can check like, but let's keep last 1 hour. So currently here you can see for auth service we have only single pod. If you want to check that, you can directly check this. Okay, kubectl describe pod, sorry, kubectl get pods -n cloud kitchen and grep auth. Okay, and here you can see for auth service we have only single pod, so it is showing only single pod. This is the P95 latency, and this is the request per second. And here you can see each and everything guys. Okay, and finally you can see Loki live logs also. Here you can see Loki is directly generating all the live logs guys. Okay, so basically we are set up this monitoring stack similarly like a real-time approach case. Okay, now if you want to see the payment service, similarly you can see for payment service. For payment service also we have only single pod. If you want to check that, directly run this command grep payment, and here you can see payment service pod we have only single pod, and here you can see it is showing a single pod, and P95 latency is 4.77 milliseconds, and this is the request per second and everything. And similarly you can see Loki logs here also case. Okay, for every service we have individual dashboards case. Okay, so now let me open this documentation once again and let me come down. In step 9, we are going to apply Prometheus rules.ml, which is available inside monitoring directory. And it's a single CRD containing 3 recording rules, meaning pre-configured metric services and speed up dashboards and 7 alert tools that covers high error rate, high latency, pod not ready, crash loop backup, deployment degraded, and data plane failures like Postgres and adds down. These files into alert manager guys. Okay, so if you want to see that, so you can directly find that Prometheus rules.ml inside the monitoring. So this is the monitoring and Prometheus rules.ml, guys. Okay, let me check that. And here you can see Prometheus rules.ml. So this is the ML. Now we are going to apply, guys. Okay, so let me go back. Let me directly jump on to step 9. Okay, I'm going to copy this and let me paste it here. Okay, let me cancel this. Let me copy this once again, paste it here. Okay, it is showing not exist. Okay, now it is going to apply Prometheus rules.ml. So here you can see it's created Prometheus rules.ml, and let me verify this. Let me copy it once again. Let me paste it here. Okay, let me apply this kubectl apply hyphen f Prometheus rules.ml. Okay, now let me check this cat Prometheus rules.ml. So let me check the namespace name. Okay, namespace. Okay, namespace we created on the monitoring namespace, guys. Okay, let me copy that command once again. So here we need to update to monitoring name, guys. Okay, namespace. So instead of Cloud Kitchen, it's monitoring. And here you can see Cloud Kitchen app rules. Okay, so this is the Prometheus rules. We created it just now, guys. Okay. Now let me open this documentation and let me come down. And here you can see these are few of the Prometheus queries. So if you want to see all the targets are up or not, you can directly run here up. Okay, let me open this and Prometheus and up and execute. So it is going to show us all the targets case. Okay, so here you can see everything is up. It is showing one. Okay, so similarly we have multiple queries case. Okay, so let's try to run one after one. Okay, so if you want to see all the Cloud Kitchen targets, you can directly run this query inside this Prometheus and execute. And here you can see this is for order service, delivery service, user service, notification, menu, auth, restaurant, payment, everything is up guys. Okay, everything is showing one. So similarly, if you want to see total HTTP request per service, you can directly run this Prometheus query. Let me remove this. Okay. And here you can see for order service, we have nearly 881. And for delivery service, we have nearly 873. User service, 874. So similarly, you can see everything in real time, guys. Okay. Now, if you want to see per route details for auth service, you can directly run this query and execute. Okay, so here you can see 288, 579 and 20. It is showing us everything. So similarly you can run all these queries guys. Okay, so I just written nearly 17 queries, and if you want to see active firing alerts, you can directly run this Prometheus query. Let me execute this. So here you can see none. Right now we don't have even a single one. Now let me go up. Okay, so you can directly run any of the query guys. Okay, it will work all these queries. I just tested all these Prometheus queries guys. Okay, and similarly if you want to see you in live logs like for auth service, delivery service, menu, order, whatever it may be, if you want to see the live pods or P95 latency, request per second and everything, you can directly watch in individual dashboards guys. Okay, and we have live Loki observation also guys. Okay, so now our app is fully observable. Metrics, dashboards, logs, and alerts are in all in one place. However, it's still served only on plain HTTP, right? Which is modern browser flag with not secure warning. And the final missing piece is real TLS. So now in phase 7, we are going to set up HTTPS via set manager. Let's encrypt guys. Okay, for HTTPS connection right now because it is showing not secure guys. Okay, so that is the final step. So you can directly follow this documentation 07 HTTPS and let's encrypt. Okay, MD5. So now let's set up this HTTPS connection for our Cloud Kitchen application. Now, in phase 7, we are going to install Cert Manager on our GKE cluster and provision a free TLS certificate from Let's Encrypt for our domain and reconfigure traffic to serve every UI over HTTPS instead of HTTP guys. Okay. So basically, Cert Manager is a Kubernetes operator that automates the whole certificates lifecycle. It talks to public certificates authorities. So Let's Encrypt in our case proves that we own the domain via HTTP 01 challenge, downloads the certificates and store it as a Kubernetes secret, and then auto renews it for every 75 days case, all without any manual work. By the end of this phase, all 5 URLs like our Cloud Kitchen application, ArgoCD, Prometheus, Grafana, Alert Manager will be served over HTTPS with a real browser trusted certificates case. Okay. So without wasting any time, let's switch to terminal and let's start setting up this HTTPS case. Okay. Before that, let me jump on to step 1. So this is the step 1 install cert manager and let me come down guys. Okay. So in step 1, we are going to install cert manager. So we will add cert manager namespace to app project's destination whitelist. And then we will create a new ArgoCD application, which is available inside ArgoCD slash apps app cert manager.ml guys. Okay. So here you can see app cert manager.ml. So this is for cert manager guys. Okay. We are going to create a new application for cert manager guys. Okay. So now let me go back and let me apply this ML. We need to apply basically two MLs. One is to update app project and second is to install this cert manager application, this ArgoCD application. Now let me copy this and let me come here and let me come out from this monitoring. Okay. Now let me paste it here and let me hit enter. Just it is going to update this cert manager namespace in app project guys. Okay. Okay, so it's configured successfully, meaning it's updated this namespace. Now, let me come down. And if you want to verify this, you can directly run this. Let me copy it once again and let me paste it here, guys. Okay. And here you can see Cert Manager is added. Earlier we have only Cloud Kitchen, monitoring, login, ingress, and ArgoCD. But now we have Cert Manager, guys. Okay. So now using this application, so this is the application ArgoCD application. We are going to install Cert Manager on our GKE cluster, guys. Okay. And if you don't want to install using ArgoCD application, you can directly install using Helm, guys. Okay. You can directly copy this and you can directly paste it here and you can directly run this Helm install command, guys. Okay. Automatically it will install this. But this is a GitOps workflow, right? I'm going to install using application, guys, ArgoCD application. Now I'm going to copy this and okay. Let me copy this once again. And if you want this ML is available inside ArgoCD apps and apps at manager.ml, guys. Okay. Now let me paste it here. Immediately it is going to create an application. Okay. So here you can see cert manager. It's creating guys. Okay. So it's healthy. Currently it's in the syncing state. Okay. So this is how it is going to deploy everything guys. Okay. Now let me open this documentation and let's check for apps, ArgoCD apps in the sense application guys. Okay. And here you can see cert manager is synced and currently it is in healthy state guys. Okay. Now let me open this ArgoCD and here it is showing degraded, now healthy. Okay. So sometimes it will show degraded, but within 30 seconds to 1 minute, it will come to healthy state case. Okay. All pods are running inside cert manager namespace. So currently it's in sync case. Okay. Sync is okay. Now let's check this. Let me cancel this and let me run this command kubectl get ns. Ns stands for namespace. And here you can see cert manager. It's created last 56 seconds ago and this is created by ArgoCD guys. Okay. Now let me check all the pods, services, deployment, replica sets, everything inside the cert manager namespace. kubectl get all -n cert manager it is going to display all the pod deployment services, replica sets, whatever it may be, it is going to display everything else. Okay. So here you can see these are all the pods. So this is the set manager pods, and this is the set manager CA injector, and this is the set manager webhook, and this is the set manager service, and this is the set manager webhook service. And here you can see these are the three deployments. One is for set manager, one is for CA injector, and one is for webhook guys. Okay. Similarly, these are the replica sets. Okay. So everything is running fine inside this namespace. Now let me open this documentation quickly. Okay. So we just verified everything, right? Now, this is option B. So right now we are following GitOps workflow, right? So that is the reason why I was creating everything using this ArgoCD application. But if you don't want to create using this ArgoCD application, you can directly go with option B using helm install command. Okay, it can directly install on our GKE cluster, guys. Okay, basically this is the second approach. But this is a GitOps workflow, right? So that is the reason why we need to follow this application sets. Okay. Now let me come down and let me jump on to step 2. Now, in step 2, we will apply a small ML that creates a cluster issuer called Let's Encrypt prod. This tells set manager two things like talk to Let's Encrypt production API at ACME-V02 API Let's Encrypt org. Okay. And we ask us to prove domain ownership, and we can do it via HTTP 01 challenge routed through traffic. Only one field really matters here, guys. Okay, you just need to update your email address, which Let's Encrypt uses to send expiry notifications, guys. Okay, so here you can see this is my dummy email address. Okay, so you can provide dummy email address, or you can provide your email address. That is not a problem. Okay, but try to update this email address, guys. Okay, now I'm going to apply this. Let me cancel this, clear the screen. Let me copy it once again. Now it is going to create cluster issuer. Okay, let me copy this command and let me keep it in watch mode, guys. Okay, so it's in true, guys. Okay, so now let me cancel this and let me open the documentation, guys. Okay, now in step 3, we will apply certificate resource, and it's a small YAML that says I want a cert for my domain, which is vijayagiri3.in, which is valid for 90 days, and it also renews 15 days before expiry, guys. Okay, using ECDSA P256 keys, which is stored inside Kubernetes secrets called CloudKitchen TLS in CloudKitchen namespace. And set manager sees and kicks off HTTP 01 challenge, and set manager responds through a ingress route, guys. Okay, within just 30 to 60 seconds. So the secret is populated with the real Let's Encrypt certificates, guys. Okay, so now let me apply this, and here you can see you need to update your domain name here, guys. Okay, vijayagiri3.in in my case, but you need to update this with your domain names, guys. Okay, don't forget this. And now let me copy this and let me paste it here, and let's check this certificate. So right now here it is showing false, right? We need to see here true, guys. Okay, so basically it will take around 30 seconds to 60 seconds to become true. So let's wait for some time. So now here you can see it's converted to true. Now let me open this documentation, and if it is stuck in false, right, you can debug using this commands case. Okay, I already created few commands for the debugging. Now let's directly jump on to step 4. So in step 4, we are going to flip CloudKitchen ingress routes to HTTPS. So CloudKitchen application is ArgoCD managed with self-heal equal to true, which means any manual kubectl apply change would be immediately reverted. So we do this in two small subsets. So in 4A, we will disable ArgoCD auto syncs on CloudKitchen application. So in 4B, we will apply a new ingress route that tells all 10 routes matches but flips entry point from web to web secure, guys. Okay, and also we add TLS secret name equal to Cloud Kitchen TLS block, guys. Okay, so this is the rule. Now let's start applying this 4A and 4B. So first let's disable Argo CD autosync on Cloud Kitchen app. Let me copy this. Let me open this terminal. Okay, let me open this terminal. Okay, let me cancel this and let me paste. Okay, let me copy it once again. Okay, so it's patched it successfully. Now I'm going to apply HTTPS flavor for all the ingress routes case, okay? Meaning for all the services, for menu service and for auth service, user service, restaurant service. We are going to add HTTPS case, okay? So let me copy this. Okay, let me copy it once again. Okay, it's completed successfully. So now let's come down. So if you want to verify, you can directly verify this, okay? So we need to check this expected. We need to see web secure cloud kitchen TLS, okay? And here you can see web secure and cloud kitchen TLS, meaning all the ingress routes has been updated successfully. So if you want to do some smoke testing, you can directly do guys, okay? For HTTPS. Now we need to see expected code as 200, meaning okay. So HTTPS is working fine for our domain guys, okay? Now, if you want to check for all the 10 microservices, you can directly run this curl commands, guys. Okay. Let me copy it once again. HTTP 404. Okay. So here you can see right now this is not the GitOps workflow what we did, guys. Okay. It is going to out of sync. Let me show you that. So here you can see Cloud Kitchen application went to out of sync. So if you want to automate this, okay, so you can directly update this case, okay. So inside GitHub repository, you need to change this everything in the helm values.yaml file, guys, okay. So directly run this commands and raise a small PR, guys, okay. Now in step 5, let's move ArgoCD, Grafana, Prometheus, and Alert Manager to HTTPS. So in 5A, first let's duplicate the TLS secrets into monitoring and ArgoCD, and let's come down. And next in 5b we are going to reapply all the three observability ingress routes to HTTPS guys, okay. So now I'm going to apply this 5a and 5b. Let me copy this. Let me copy it once again. Let me copy this. Okay, so it's created Cloud Kitchen TLS. Okay, so it's created this, okay. And here you can see both are created successfully. So now let me open this. Now I'm going to apply three observability ingress routes case. Okay. So earlier we created with only HTTP, right? For Grafana as well as for Prometheus and as well as for Alert Manager. We just created with only HTTPS, right? So now what we are doing, we are updating with our TLS certificate, guys. Okay. So here you can see TLS. So the secret name is Cloud Kitchen TLS. Okay. So just now we created this. Here you can see Cloud Kitchen TLS. Now I'm going to apply this. First, let me copy this. Let me copy one by one. Let me copy this Grafana, paste it here, hit enter. It's created, meaning it's just configured, guys. Okay, it's just updating this TLS. That's it. Instead of deleting and recreating. Now let me create for Prometheus, and this is for Prometheus. Okay, and we need to see configured. Okay, it's configured. Similarly, let's do for Alert Manager, and this is for Alert Manager, and this is configured. Okay, so it's completed. So now let me come down and let me also update ArgoCD ingress route with TLS secret. Let me copy this, paste it here. Okay, so we are converting every ingress route to HTTPS, guys. Okay, so now let me come down. So in step 6, let's verify all 5 URLs with HTTPS using curl. So you can directly copy all this and you can directly paste it here, guys. Okay, so here you can see expected output. We need to see 200, 200, 200. Okay. And last one is okay for alert manager. Okay. So everything is working, guys. Okay. Now let me come down. In step 7, we are going to add HTTP to HTTPS redirect. So after step 4 and 5, every route is bounded to web secure on port 443 entry point. So nothing lessons on port 80 anymore, guys. Okay. So plain HTTP request returns the 404 not found. So to fix this, we will apply a traffic middleware plus wildcard ingress route that catches every HTTP request on port 80 and listens a 308 permanent redirect to HTTPS version of the same URL, guys. Okay. So it's given a low priority. So set manager own HTTP 01 challenge routes, guys. Okay. So now let me apply this. Okay. So before applying this, let me try to access all our services using HTTPS. Let me drop down this. So this is ArgoCD, right? So here you can see when I was refreshing this page, ArgoCD is showing 404 page not found. Similarly, if I refresh this, here you can see 404 page not found. Here we are trying to access with HTTP, but when we are trying with HTTP, it is showing 404. Let me try to access Alert Manager. Similarly, Prometheus. Okay, similarly, Grafana. Okay, so 404 page not found. Okay, so it is not redirecting HTTP request to HTTPS case. Okay, so now let's try to access with https colon// vijay.in slash argocd, and okay, it is not showing, not secure. Let me debug this. Okay, let me open other service, http yes colon// vijay.in slash grafana. Okay, so browser is showing not secure. So let's do one thing. Let's apply this ML first. Okay, let me copy this. Let me paste it here. Okay, after this, let me verify this. Okay, so expected is 200. We need to see. Okay, so everything is redirecting successfully from HTTP to HTTPS. Okay, now let me try to access it once again. Let me refresh this. Okay, let me refresh this. Browser is showing not secure. Okay, let me close this entire browser and let me open here, guys. Okay, http colon// vijay.in slash grafana. Okay, now here you can see it is showing secure, connection is secure. Okay, so that is the browser's problem. Now let me open Prometheus, http yes colon// vijay.in slash argocd. Okay, so we can able to access ArgoCD, and here you can see connection is secure and the certificate is valid, guys. Okay, similarly, let me open Prometheus. Let me copy this URL, guys, instead. Okay, copy this and paste it here and slash Prometheus, and we can able to access Prometheus. Okay, now let's do one thing. Let's try to access with HTTP, guys. Okay, let's try to access alert manager with HTTP. Okay, instead of S, it will automatically redirect to HTTPS, guys. Okay, so here you can see it has redirected to HTTPS. Now connection is secure because let me open this. We created this middleware as well as this HTTP to HTTPS redirection, guys. Okay, so that is the reason why this HTTPS redirection is working. So now finally let's try to access our main application, http colon// vijay.in. Okay, simply vijay.in. It will redirect to our CloudKitchen application. Okay, so we are trying to access with HTTP, but it is redirecting to HTTPS case. Okay, so here you can see connection is secure and the certificate is valid, guys. Okay, so now let me drop down this and let me keep this here, or else let me keep this here. Grafana, let me keep it here. Prometheus, let me keep it here. Similarly, and alert manager. Okay, okay. Now let me open this ArgoCD, and we need this ArgoCD username and password, right? Let's directly jump on to ArgoCD deploy.md and let's run this command, guys. Okay, copy this and paste it here. It is going to show us the username and password. So the username is admin. So this is the password. Copy this, admin, and password is this, and sign in. And here you can see all the applications are deployed successfully. So now let me try to log into Grafana. So username is admin and password is from operator. Okay, so it's connected to Grafana, and let me open dashboards. And here you can see for every service we have individual dashboard, guys. Okay, previously as I explained. Let me open payment service now, and let me refresh for every 5 seconds, and I need last 6 hours data. Okay, or else 3 hours data. This is fine. Okay, so you can see all the how many pods are running inside GKE, 95 latency request per second, and the Loki logs. This is the main thing, guys. Okay, everything you can see here for all the microservices. And if you want to query anything on Prometheus, you can directly query everything inside this Prometheus case. Okay, and now finally let's do one thing. Let's try to test this application by placing some orders and by running some Postgres SQL queries, guys. Okay, so initially you can directly follow this Postgres database guide. So let me run this very first command. Let's see all the registered users. Let me copy this and let me paste it here. It is going to show us all the registered users. And here you can see currently it is showing 0 rows, right? Now I'm going to register a new user. Let me open CloudKitchen and sign up. vijay@gmail.com. Okay, let me provide only full name as Vijay. Email vijay@gmail.com. Password vijay@123, and it's the customer sign up. Okay. Now we currently created an account, right? So now we need to log in using that account. So the account email is vijay@gmail.com and password is vijay@123 and login. Okay. So now here you can see we are in the login page. So here this is my profile, guys. Okay. So now let's run that command once again. We need to see user one. And here you can see vijay@gmail.com. So role is customer. It's created, guys. Okay. Now let me come here. Now I'm going to place a small order. So let me select here Hyderabad and Vijay's Pizza. And let's select BBQ chicken pizza. So it's added to the cart. So this is handling by the cart service. And let me select to proceed to checkout. And this is handling by the payment service. Let me provide delivery address as test, and payment method is card. So this will be handled by the payment service. And now here you can see notification is sent, right? So this will be handled by the notification service, guys. Okay, so end-to-end application is working fine, and you can directly run all these queries if you want, guys. Okay, so if you want to see total accounts, you can directly run this query. Let me remove this and let me run this query. You can see all the total accounts. So total users are 1. Okay, now let me come down. So similarly, let's try to create one other account. Let me come here. Let me show you how it is working. So let me select here logout and sign in. And now test@gmail.com. Okay, so this is the full name. Full name is only test. Email test@gmail.com and test@123 and sign up. Okay, so account is created successfully. Now let me run this query once again. It is going to show us a total number of accounts, sorry, users. So currently we have two users. Okay, one is Vijay and second one is test. So if you want to see like this, run this command. So here you can see test@gmail.com, vijay@gmail.com. Okay, so here there is a small typo. So let me copy this, guys. Okay, otherwise it will fail at login. Let me paste it here and test@123. And here you can see welcome back. So now this is another account, test@gmail.com. Now let's place some other order. let's select here Bangalore, the green bowl, and I'm going to order this salad, and it's added to the cart. And let me select your view cart and the place to check out, and let me order this. Test address is test, and payment. Okay, so this will be handled by the payment service, and order confirmed price. Okay, so here you can see order has been placed. So now this is how it is going to work, guys. Okay, so you can run multiple Postgres SQL queries. So here you can see, so these are the, if you want to see total profiles, you can directly run this query. Okay, so total profiles, so here is two, guys. Okay, now let me come down, and if you want to see every restaurant, active restaurants only, you can directly run all these queries, guys. Okay, all these queries will work. And if you want to see all categories, you can directly run this, and let me come down. And if you want to see every order, you can directly run this query. Let me copy this, let me paste it here, and here you can see total we have two orders. One is from Vijay account and one is from test account, guys. Okay, so let me come down, and if you want to see all the payments, you can directly copy this and paste it here, guys. Okay, okay, let me copy this properly. And here you can see currently we have two orders. So these are the order IDs and these are the IDs. And one order amount is 240, one order amount is 400. So both are card, and status, one is failed and one is success. Okay. Now let me come here. So if you want to see all the delivery agents, like all the 10 agents and their availabilities, you can directly run these queries, guys. Okay. Now let me come down, and all notifications. If you want to see all the notifications, so you can directly run this query, and this will be handled by the notification service, guys. Okay, copy this, paste it here. Okay, and here you can see we have total four notifications. Channel is via email. Okay, like order placed, delivery updated, payment complete, order placed, something like this, guys. Okay, so this application is going to work really like a real-time application, but again, this is not the real-time application. I created this entire project only for learning purpose, guys. Okay, so if anyone want to learn this GitOps workflow, they can directly follow this entire approach, guys. Okay, so similarly, I created this process like a real-time, guys. Okay, now these are some useful dashboard queries. You can directly run this. Okay, so, and yes, that's it for today's video. And if you want similarly like this video, recently last 1.5 months ago, I created one other video. Let me show you that. Let me open my YouTube channel, and let me select here Vijay Gidituri. And here you can see this is the project base. Okay, so similarly this project I created using Jenkins, Terraform, and Docker, and it's a multi microservice project base. Okay, and this is a travel booking application, and now we deployed a cloud kitchen application. Okay, in this application we have nearly 10 plus microservices, right? So similarly in this project we have nearly 10 plus microservices case. Okay, there we automated using Jenkins, and also the best thing is we installed Jenkins on Google Kubernetes engine directly, guys. Okay, so try to watch this video, and if you want this repository, so you can directly find this travel booking repository link in the video description itself. Okay, now I will provide this Cloud Kitchen repository in this video description, guys, parallelly. Okay, so and yes, that's it for today's video. And after completing this project, try to delete all these resources, guys. Okay, because Google Cloud will charge some amount. So that is the reason why after completing this project, try to delete all these resources, guys. Okay, firstly you need to delete all the Terraform scripts, guys. That's it. Okay, and after that we created GKE cluster manually, right? So we need to delete that Google Kubernetes engine manually. That's it, guys. Okay. So let's delete all these resources. So initially, first we need to delete our GKE cluster because we created GKE cluster manually, right? So now let me select this. Let me open my Google Cloud account, and let me directly jump onto Kubernetes engine and clusters. And this is my cluster, right? So you need to select this cluster and delete. and directly provide the name of the cluster case. Okay, so this is the name of the cluster and delete. Okay, so now this cluster has started destroying, and after destroying this cluster, right, you need to run this command. First you need to enter into this gcp-terraform directory and terraform. First let me run this command terraform state list. So currently we created vpc, subnets, cloudnet, cloud router and everything using terraform, right? So we need to destroy all those resources, guys. Okay, meanwhile fail to open state. Okay, let me check the state file. Let me open cloud storage and let me select here buckets. Okay, so we have this. Let me come here. Let me do this. Okay, terraform init. Fail to get existing workspace gcloud storage fail. Okay, let me do one thing. Let me come here and let me run this command, guys. Okay, let's see. So here you can see after exporting these credentials, again Terraform init is working. Now let me run this command Terraform state list. It is going to show us all the state information, like all the created resources like artifacts, firewalls, and network, router, NAT, and subnetwork guys. Okay. So after that we need to, once GK cluster is deleted, right, we need to delete all these using Terraform itself guys by running this command Terraform destroy hyphen hyphen auto hyphen execute. Okay, but we need to wait for some time till this cluster deletes guys. Okay, so let's wait for some time. So here you can see cluster has been deleted successfully. So now let me run this command. So this command is going to destroy all the resources which is created by Terraform guys. Okay, so here you can see all the 8 resources were destroyed successfully. So now let me open VPC network and VPC network. Okay, so here you can see we don't have CloudKitchen dev VPC, and similarly let me check for artifact registry. And here you can see we don't have a single repository guys. Okay, so it's deleted successfully. So finally let me delete this IP address. So we manually reserved one IP address, right? So here you can see traffic load balancer IP. Try to release this static IP address guys. Okay, because this is not free, this is a paid service guys. Okay, now it's released. Okay, so and yes, that's it for today's video. So I will provide this GitHub repository link in this video description, so you can directly clone this repository guys. Okay, so and yes, that's it for today's video. And if you like my video, please do like, share and subscribe to my YouTube channel, and see you in the next video, and bye.